do the count in, even though it's doing that.
Mhm.
All
Game
right,
start.
and I'm also going to start some music up because of
All
reasons.
right. How's my audio levels? Are they okay?
Yeah, yeah, you're good. I can hear you just fine.
Perfect.
All right, what am I looking for? I'm looking for my console. All right, so you should be able to hear music as well, maybe.
I do.
Is it too loud for you?
No, it's good.
All right, cool. So we got that going. What else do we need to do? I guess I can add you. So I'll add you to the right. Go to a guest.
What's your Twitch handle again?
At Code and Color, I think. Yeah, Code and Color.
Okay. Cool.
Yeah, I wanted. I tried to change it to I am Will Shepherd, but because I own I am Will Shepherd, it's like you can't do that. And then I deleted I am Will Shepherd. And it's like you can't change it for 3 months. So I'm like, cool. I waited 4 months and tried to do it. It's like, oh, you can't do it. I was like, fuck it, and I gave it up.
Are you kidding me?
Nah, I mean, you've used software services on the internet these days. Like,
Oh yeah, tell me about it.
I was just like, you know what? Okay, it's fine. I'll just keep it with Code and Color.
So code and color, no spaces.
Code in color, no spaces.
The letter N.
Yeah, I think. Hold on, let me. Don't quote me on that. Let's see. Okay, that didn't do what I expected it to do. I actually don't know my thing. My handle.
We're both learning new things today.
Oh, here you are. All right, it's code and color. It's like in I
Code
N
and
color.
color. Code in color. Oh,
Yeah.
I got it.
Yeah. Cool. So I got that figured out. Look at that.
Oh wow, this is coming up smooth.
Oh, you're seeing it? Oh, you're good.
Yeah, I'm seeing it on Twitch.
But it's just me and you at the moment. I think, right?
Yeah.
Okay. So let me go ahead and lock that screen, and then guess I'm gonna go to my share screen just to make sure that we look decent here as well. So we'll add you down here. All right. Oh wait, I'm sorry. I'm supposed to be showing you these things. Let me bring these over. So you're not going to see this on the stream. It's going to get confusing. I'm sorry. It's not my fault though. So you got to watch this in Zoom to see what I'm seeing.
Okay, I'm on Zoom.
All right, perfect. So let me kind of get rid of this.
By the way, I don't know if you know this, but someone during my batch at Recurse set up a bot, kind of like the blogging one, where if you go on stream, it'll log out in Zulip that you're live, so people can like tune in.
Oh, really? Okay.
Yeah, so that might be worth for you to look into. Maybe get more people to watch.
Yeah, that's something. Honestly, we should do that together at some point. Like once we get some like, I don't know, just things working. I don't know. It's difficult. There's a lot of stuff going on, and I think you're going to get to see it today. All of
Okay,
this.
I'm excited.
So all right. So we got Ecamm here. Let's also bring over my overlays as well as my interview panel. All right, so you should be able to see all of Ecamm, right? So you see this black window in the middle?
Yeah. Yep.
Okay. All right, perfect. So this is how you can create scenes within Ecamm. So at the moment, you see how like you're down here. What I can do is I can come and unlock this particular thing. It looks like maybe I can do that right there. So I can kind of move you around. So if you look in the stream, you'll notice that like you're moving around in the stream.
Yeah.
Right, so this is how we can like create these custom scenes. At the moment, I'm sharing my screen. However, there's another option that I have, which is to share whatever the current application is. So if I go on and click on here, you'll see that it's only showing this application. Or if I click on music, it's showing you music on the screen. And this is where it's a lot clearer because it's zooming in.
Yeah.
However, I can also do this and say don't zoom in, and it'll just render it at the resolution that's on my screen. And as I move it around, you'll see it move around, and you'll see that it's being clipped, and that's because I have a vertical monitor. So this is all on the vertical monitor. However, if I come to my main monitor, I can move it all around. And
nice. And it'll follow it across monitors.
Yeah. So now I'm on my third monitor on the right, and it's still doing the thing. So I only use that every so often because when you do the zoom to app window and you come to something like this, for some reason Mac OS will render this out as white instead of black, and it annoys me. So that's why I tend to not use this.
What was causing the whiteness?
I think it's Mac OS, the way it renders, because there's no screen there. So I think it just renders it as white instead of black.
Oh, okay.
Yeah. Now, if it rendered it as black, that would be better for me because, as you can see, in the stream, my desktop is black. However, on Zoom, you actually see my desktop, which is whatever the sun's colors are.
Yeah. Oh, that's cool.
Yeah. So it's to me, it makes it easier to have people focus on whatever I'm doing versus all the crap that may be going on in my on my machine. All right, so the way I created this was I created a new scene. Oh, go ahead. I'm sorry. Are you there? Oh, I think you froze again.
So, yeah, my connection crapped out a little bit there, but I think it should be back.
My bad. So I was just about to go over adding different types of overlays. So at the moment, I have a chat box. Right now, no one's chatting. However, if somebody were to drop a message in the chat in Twitch, it will show up here. And you can. So
if I leave a message there,
I might be able to add a message. Let me do it to only Code and Color. Oh yeah, I see you. I got a new follower. Oh, thank you for following. So yeah, you see that like I also have these alerts. That's what you just saw. So if any type of alert that I've subscribed to happens on my stream, you'll see that here. And here's the alert box right there. And then I also have an emote wall. So people who do the emotes, they'll just show up there at the top.
Nice.
All right, and then some of the other things that are kind of cool about this is that not only can you select which monitor to show, so like let's go to let's hide some things that may not should be shown. Nothing bad, just more private stuff. So if I come to my secondary display, oh sorry, that's you. So you see the zoom window and what's going on that machine, and then here you get my vertical display. So that's the other cool thing about this is that I can go and select which display to show, which application I want to show, as well as just show the current application and zoom in. And I can also zoom into content. So let's say I'm here on Ableton, I can zoom in. I have to get to my window. This is why I keep my window on another screen, by the way. It's so that I can control these types of things. So I can zoom in anywhere on Ableton. So if I'm trying to show you a specific thing, I just do that. And
I have to go back not on Zoom to see that.
Yeah. This is on the stream. My bad. I know it's confusing.
Okay. Oh wow, that's cool. So what are you doing there? Are you doing that thing on Mac where you hold down Control and like zoom in?
Nah. So on Ecamm, you just do your scroll wheel and it does it within the stream itself.
Oh, okay.
So it's not affecting anything on my screen. This is only in Ecamm, and I just move my mouse to where I want to zoom in and then just scroll. And this is how say for instance you can't read something, I just go in and we can focus in on a certain area.
And it looks so crisp. It's like not pixelizing as it zooms in. It looks very sharp.
Yes, and that's because it's actually taking the signal in at 4K.
Wow.
So I can zoom a lot and I'm not going to lose resolution. However, on the stream side of things, it's outputting at 1080. So once it comes out, then it's going to lose the quality. And then there's also the compression that's going on the transmission, as well as from YouTube or from Twitch when it's giving it back to you.
I see.
All right. And I'm just now realizing that you're seeing my screen in Zoom. So what I'm going to do is change my camera for you. We'll just go to this camera. Or we can go to the studio display camera. I think you'll be able to see more stuff. Maybe. Yeah, maybe.
Okay.
No, you can't. I was hoping that it would show other stuff, but it doesn't. All right. Anyways. Yeah. So I think we got some good stuff going on. We can hear each other. It seems like the video's happening just fine. Let me go ahead and turn on my stream from my end. Yeah, we can get into it. What kind of stuff are you interested in going over today? What do you want to talk about?
Yeah, I mean, I'd be excited to learn more about your setup, and if we could like draw out maybe on like Excalidraw or something, like what components are, what's feeding into what, go over some of the terminology.
Yeah, absolutely.
That could be pretty cool.
That works. Are you able to, can we do collaboration on Excalidraw, or do I have to have the paid account for that?
I think you can. I think it should be free.
Okay. All right. Give me one moment. Let me.
I can send you a link.
Yeah. Send me a link.
Okay.
All right. I'm trying to make sure that the stream is working on Twitch. I guess I'll just watch it on YouTube. I cannot open this. Oh, there we are. Give me some more time to like move stuff back to where it was. I typically have a whole setup, so it's like I don't have to do it. So we'll put my comments back to where they were. One thing that I would love to do is have a shortcut that whenever I live stream, it automatically arranges, certain applications, open certain applications, start certain things. Because right now it actually takes me between 2 to 3 minutes.
Like a window manager thing. There's something called Hammerspoon for the Mac. You might want to look into that.
What does it do?
It's like Mac automation kind of stuff. Written in I think you configure it with Lua, but I believe you can use it to do windowing.
Yeah, that would be ideal. I mean, I use a tool, but it requires me to do stuff, and I don't want to do anything. I want to set it up once and just say, all right, whenever you notice that I'm doing this thing, just do the thing. You know what I need, just do it.
Yeah, I hear you.
All right, I'm almost finished. And you can't see any of this, that's why it's like walking through it. All right, so we got comments up. All right, cool. So where should we start? Should we start at video or audio? What signal chain do you want to start on?
Video or audio? I guess I'll leave it up to you. I don't know enough about either to like.
All right, we'll go with the simpler of the two, which is surprisingly.
I like that.
Video. All right. So.
By the way, when I talk, I notice like it really mutes your voice. Is that a Zoom thing or?
I think that's a Zoom thing.
Okay.
Yeah.
Okay.
Let me see. Wait a minute. There is a setting in Zoom. I'm going to see if I can show you how to get to it. All right. So if you go into audio, what you may want to consider, especially because you have a decent mic, is make sure you go into original sound for musicians. And then make sure you select high fidelity music mode and stereo audio, and make sure that you don't have echo cancellation on. And what that's going to do is whenever you are in a Zoom meeting, you will have a new UI element that says share. Here, let me stop sharing. Oh, shit, never mind. If I stop sharing, oh wait, you'll be able to see it. Let me just bring it over to here. All right, so look at the stream now. Sorry.
Look at the stream.
So you'll get this new UI bit right here, original sound for musicians. Just turn that on. And that may do the trick for you.
Oh.
Yeah, so try that out.
So what exactly happens when I turn that on?
When you turn it on or when you turn it off?
When it's on.
When it's on, it's going to turn off Zoom's noise suppression. It's going to turn off the input level. So like it's always changing your output to give you the best volume. So you're going to have to do all that yourself.
But yeah, so I do hear an echo now with echo cancellation turned off.
That's, yeah. So there's some things that we will have to do on your system to make sure that doesn't happen. And this is where the complexity comes in. So for now, just turn it off, and like we'll go back to how it is, and we'll cover that in the audio tool chain, I suppose.
Okay.
All right. So for some reason, I can't hear you as well anymore. It's like you're lower. Is it my fault? Maybe it's my fault.
Let me see my input levels. I think dropped a little bit. Let me try to up it. Like, does that sound a little bit better?
Yeah, it's better. All right. So let's go back now. I'm also close this because it's going to confuse me if I keep coming back to it. All right. So first thing for video, do you care about the type, like the brand and all that kind of stuff, or how much do you want to know?
Just, I guess we could keep it high level.
Okay.
But I don't know if our audience of whoever would be interested in the details.
Actually, let's see. We have someone here. I'm back in Azerbaijan anyways. What's the Zoom thing might fix it. Actually, you know more than me. Well, hey, what's up, Factory? How you doing? I just now saw your message, so my bad. Hopefully you're doing well. For what it's worth, Factory is based in UAE. And
very cool.
He's actually in high school.
Oh, no way.
Yeah. I'm like, last time he was here, I was saying how it's pretty awesome that like he has access to stuff like this, where when I was in high school, and I imagine when you're in high school, what's the likelihood that you're able to talk to a real life software engineer who maybe has built software that you use? Like, what's the likelihood?
Insane,
yeah. So I was just like, man, like that's kind of dope. So make the most of it. Any case, so we have my video camera, and we have a encoder that this runs through. So we have a encoder, and technically this is a H265, or it may be a 264 encoder. We'll just saying we'll do 264/5 encoder because I'm not sure.
Okay.
All right. And this is via HDMI.
This is a hardware or software encoder?
This is a hardware encoder.
Okay.
Yeah. So it has the the dedicated hardware to encode from whatever my camera's outputting into something that my computer can read as a webcam. So it's literally your cam link. Your cam link's doing this.
Okay.
Yeah. All right. So I go into my encoder, and then here is I have my CPU, my computer. And I guess we could just do that. And within the computer, there is some. Oh shit! I didn't want to do that. All right, so within my computer, there is Ecamm. So that's. All right, so the feed comes into my computer, and then I read in that feed into Ecamm. Can I change the style of that? Maybe. Yeah.
So video here is like your camera, right?
Right.
Okay. Yeah.
Yes. And then this right here is my hardware encoder. I don't know why that did that, but let's. All right. And then within Ecamm, this handles all of my switching. All right. So I'll just put like a little blurb here. So handles scenes and switching. And maybe I'll be very clear. This is AV switching.
AV switching. Okay.
So I'm specifying AV because it also does audio switching based on the scene. So if I have, and let me bring that over. I think you'll. Am I sharing my screen with you right now? No, I'm not.
No.
Okay, I have to reshare my screen. Okay, so this little window right here is tied to the scene that I'm on. So let's say that I mute this particular thing on this scene. Whenever I come back to this scene, it'll be muted. And if I leave this scene, it'll be whatever it was set for that particular scene. And that goes for movie sound effects as well as the volumes. So it's all per scene. That's what I mean by switching in that case.
Okay.
All right. All right. So with an Ecamm, this is just my video, or I guess my camera. I also have my microphone. And this is going through an audio interface. And this audio interface has DSP built in. Like it has 2 DSP chips built in. So
Okay.
we'll just say this includes DSP. DSP is digital signal processing for those who watch
Gotcha.
this on VOD.
And what does it do? Like it just makes it sound better? It does some optimizations and stuff?
The DSP allows me to control what the signal sounds like before it even gets to the computer without using any of the computer's resources. And it allows me to do this in real time with no latency.
Okay.
Yeah, and that's
so
the
things like
important bit.
equalizing and stuff like that?
Equalization, saturation, compression, pretty much anything. In fact, I will show you some of this. So let's show this little thing right here. You can see this, right?
Yeah.
Okay. All right. So this channel strip here is being, like, all of the processing is happening on my UAD audio interface. So let's say that I want to change how something sounds. So I'm just going to turn on this filter here, and we're going to do a low pass filter. So let me turn it on first. All right.
So you're controlling this through this software. You're controlling your hardware audio interface.
Right.
Got it.
Yeah.
So okay, so it's happening a level before your computer, even though like the UI right here is on your computer.
Right. Yeah. But I can also control it from my device itself.
Okay.
But there's a lot of stuff that I can't control from the device that I have to use this for. This is the console. So I'm going to change my voice a little bit. So as I move this around, it should change what things sound like. I don't know what it sounded like, to be honest. But
I don't notice much, to be honest.
Let's see. Let me turn it up for myself so I can hear myself. And I also want to make sure that I'm actually using it. Okay. So it looks like this isn't going to do it. Let's do something where you're actually going to be able to hear. So I'll turn on this, and let's just turn down some frequencies, all frequencies maybe. All right. So you should be able to hear something. If you don't hear something,
I think I did. Yeah.
If you don't hear it, then it could be me. Let's do this so I can actually. You should all see what I've been able to do. So I just change this from monitor to UAD record, which means that it'll only happen on the out, and I won't hear it here.
Okay.
Hard to explain. Anyway.
Yeah, I see that word monitor a lot in audio. Is that just when you can hear what's going out?
Yes. Monitor is just like a monitor display. So monitor display is for you to monitor what's happening. And audio is for you to monitor what's happening, but in audio we hear it with our ears.
Okay.
Yeah. So yeah, that's whenever you see mon, it typically means monitor. Monitor also means monitor. You will generally never see mono to mean monitor. So there's also mono.
Got it.
All right. So let's undo all of these things. How do I do that? Go to my preset. I don't want to do that. I just want to open it. Okay, all right. And I'm also going to do it here because this is my first like tool path. You should really hear this. I'm going to jack up the peaks, and I'm also going to jack up a frequency that you're likely to hear, which is 2K. And you should hear it's like a lot more nasally and all that kind of stuff. This is all happening with almost no latency and happening all on my device. And the no latency is important because if you're monitoring, like when you say something, you probably want to hear it as you say it, just like when you don't have on headphones, you hear what you say immediately. So if there's delay or latency, well, you may say something, but you may not hear it for like half a millisecond or a second. So it's like with video, when like if you don't see the video in sync with what you're doing in real life, it's a little bit weird. It's the same concept here. So latency is our enemy. So
that makes a lot
that's
of
why
sense.
we spend all this money, is to get rid of latency in our systems.
Amen.
All right, but you're able
so
to hear
what's
this
your-
one, right? This difference.
Yeah, this one was very apparent
Okay.
when you were modifying the knobs here.
And I should also add that because we're going through all of these different layers of abstraction and it's going over the internet, there are certain things that you may not be able to hear, just by nature of the fact that, for one, I'm not using original audio on Zoom, and for two, it's like it's still going to compress it and do things. So a lot of the nuances you won't hear. However, if you have like a studio monitor, like I have studio monitors here, you can actually hear it very clearly if you have the raw file. So what I may do after we finish the stream is I can share this with you, the original file, so that you can compare what it looks like on the stream versus what it looks like when it's recorded.
Oh, interesting.
Right?
Okay.
That's another reason why I use Ecamm. It's because it's recording locally. Unfortunately, they only allow you to record in the resolution that you stream, which, yeah, I've asked for this feature to say, hey, like, can we decouple these things? Like, let me record in 4K and stream to 1080. Like, I know you could do it because, like, I mean, technically you're doing it now, but you're locking everything anyway. So let's go back to here. So this whole thing is going to be our computer, so I'm going to kind of move this around. So we get into our computer. Video goes to Ecamm.
Okay.
And I'm also going to use the same stroke style just so that it becomes a little bit easier to read, hopefully.
Mm-hmm.
All right, so within the computer, once I get into the computer from my audio interface, we're going to go to a software called Loopdeck. Not Loopdeck, or is it Loopback? Loopback. All right, and this piece of software allows me to, oh yeah, if you can organize it for me, that'll be even better. So this
I was putting a link there.
Oh,
Boom.
really? Oh, okay.
Now you can click on it.
Perfect. Yeah. I'm glad that we're collaborating. That's easier. All right. So Loopback allows me to set up virtual audio devices on my device. So I have a few.
I tried to use Loopback once and I got so overwhelmed that I uninstalled it. But
well, do you still have it? Like, do you have a license for it?
I was on the trial.
Okay. Well, you'll re-download it after this. We can show you how to do that. So I have a few devices here. I have one for a monitor. This is for my stream whenever I'm using Audio Hijack. I will bring that up right quick. I just won't start it.
You have a monitor for when you're using Audio Hijack. Okay.
Yeah, so here is my setup for Audio Hijack. And
Quick aside, I forget what Black Hole does. I downloaded it once because I think what I needed was to record a Zoom video that someone was speaking on Zoom and I wanted to record it.
Mm-hmm.
So I think I used Black Hole somehow to record my whole screen and save it as an video and audio file to disk.
So
is it like a pseudo audio in or something?
Yes and no. So it's for audio only. And they have two different versions or three different versions. There's a 2-channel, a 16 channel, and I think there's a 48 channel. And what I look at it as is a sync, right? It's a sync for audio. Sounds a little weird, but like just think of it like a place that you can reroute any audio on your system into that place, and you can then listen to that audio as input from any other place. So it's a virtual channel or virtual audio source. It's very similar to what Loopback is doing, except this allows me to have things that are outside of Loopback.
Oh,
so
it's almost like a variable.
I think you can
programming.
Yeah,
Something like
think
that.
you can call it that. Let's go to my audio settings so we can show that. All right, so where is Black Hole? So you see I have two of them. I have the 16 channel and the 2 channel. So what this allows me to do is actually, here, how about this? I can show this in real time. So we'll open up a new thingamajig and let's do input device. All right, so I'm going to select my Black Hole 16 channel. And if I come down to advanced, you'll see here I have all these channels that I can select. All right, so let's say for instance, I had you, if I had some routing where I'm routing your audio into Black Hole channel 10. Well, what I can then do is come into here and like, because I'm routing all your audio into Black Hole channel 10, it's going to show up here. So whenever you talk, I will see the meters go up and down, and then I can route that audio however I like. So it gives me more channels so that like, if I have like 3 or 10 people, I can create 3 separate channels or 10 separate channels for these people, and then I can individually route them to however I like.
So cool.
So hopefully that gives you a little bit. Of course, you'll build more understanding. If you don't get it now, don't worry. Over time, I swear.
No, I actually get it. You can almost like multiplex different audio streams into that one channel, 16-bit, 16 channel one. Nice.
Exactly. Yes. And on top of that, not only can you keep them as distinct channels, they can also be muxed together and summed together. So like it's either all or none. It's not like you can only do 2 or 3. It can just think of it as a mixer. So if you have a 16 channel mixer, typically there's one out, so it's all being summed to that one output.
I see.
So you can do that here. However, the other side is that you can consider it as it having 16 different sends, where instead of just muxing that audio, it also has the ability to send that audio to some other path in addition to being summed. And that's what I was just showing here. Okay,
that was enlightening.
Yeah, it's a lot. I'm not gonna lie. So this monitor, for the stream, this is for this audio hijack here, and the reason why I do this is because I have some things going. Like I have a like this tool here to add like vinyl noise, as well as add like distortion and wobbliness, like that it's going in and out kind of thing. I have that here, which I can't do without this application. So because of that, I had to make sure I route the audio to a place that doesn't clash with the audio that Ecamm is recording. That's why I have these separate monitors, and you'll notice that they're all external things like my headphones, my monitor here, my studio display, or AirPods. So this is how I'm able to listen to my stream audio over my Bluetooth headphones in some of my streams. And this is important because if something breaks, I will know because I can hear it.
Got it. So what you're listening to right now is what exactly? Like, is it?
At the moment, I'm listening to whatever. I'm listening to what's going into Ecamm at the moment.
Got it.
Although,
so
yeah, go ahead.
So Ecamm is like Black Hole channel 2. The out of Ecamm is coming through that, and then you have the monitor set up so you can listen to it. Here, I'll show. So let me bring over my sound. So at the moment, I'm not using the monitor, so I can effectively turn that off. I'll just turn it off just to prove. And I'm also not using stream at the moment, so I'll turn that off.
The only thing I'm
Okay.
using is Zoom. And what you'll notice is that this level here, it only goes up when I say something.
Okay.
And
And me
when-
too, right?
and
Like
when
if you
you say
turn off
something.
that, you wouldn't be able to hear me. If
Exactly.
you turn Zoom off. Okay.
Exactly. And when you look at the source, you can see why we're getting audio. So I'm using my UAD as a source, and you can see all of the inputs that are happening right now. I'm in channel 1. All right, so that's me. You're in this channel 5 through 6. You're basically in the
5.
summed channel. And
I'm in the what channel?
the summed channel.
The sum channel.
Yeah,
Okay.
basically the output channel.
Okay.
Let me bring over the console.
And so why weren't you getting double audio of yourself, like when you had the monitor on too?
When I have the monitor on,
Yeah, like before when you had the monitor on, wouldn't that create like a double audio?
not quite. And here's the reason why. So you see this input is the black hole channel, but the only thing that's outputting to that black hole channel is audio hijack here. But currently I'm not running this, so there's no output going into black hole channel 2 or 2 channel.
Oh.
So
okay.
because there's no input, like you won't hear anything. Makes sense?
Whoa. Okay. So basically, audio hijack. You're doing all this stuff to get that black hole output,
Yeah, I do it all to that black hole output, and
and then this is the input in loopback
yes,
then that's the end of the pipeline.
yes,
Got it.
yeah. So it's like you're pointing to black hole channel, and it's always pointing at an input. So if there's nothing, I'm sorry, it's pointing as an input. But keep in mind that black hole channel can output audio. So as long as there's audio being output, this is going to get it on the input side. It's a little confusing, but I think it's just because it's abstract.
Got it.
How can I? So let's say, for instance, you have a physical mixer, and I'm sorry I have to keep going back to physical mixers, but you have one that's similar. Like you have your Rodecaster Pro.
Yeah.
You have audio that can be going into that Rodecaster Pro, but that doesn't mean that you plugged it into a speaker, right?
Yeah.
That doesn't mean you can hear it. However, you can also like have that audio or have your Rodecaster Pro plugged into a speaker, but that doesn't mean that you're going to hear anything because there may not be source sound coming through your Rodecaster.
Yeah.
Well, here's how the black hole comes into play. What if you have 2 Rodecasters? Isn't it possible for you to route the output of one Rodecaster to another Rodecaster?
Yeah.
And if you were to like say that out loud, you would say, well, this Rodecaster is the input to this Rodecaster. So if you had 2, you're just saying I'm going to route the output of one into the input of the other. So we look at the input of the other as the name of the source. In this case, it would just be Rodecaster. I hope that didn't just add more confusion. I'm trying.
I think I got it.
Okay. It's a lot, to be honest. Yeah, it's a lot. But I'm going to go ahead and turn this off, and we'll come back to here. And before I go more into here, I also want to kind of say why I'm doing this. So you see that there's a bit of a pass going here. Like I have my input source, which is my UAD. And then I'm running that through an EQ, a custom EQ. And this EQ is matched to this EQ here. Right. I can't show them both, unfortunately. But if I just move it closer, maybe, you see how when this goes up, this one goes down. That. And then this just has like the typical bump that I would do just to make it a little bit more present whenever I'm speaking. So yeah, this is just a little bit about EQing, just making sure that if you're trying to balance 2 sources, we have limited bandwidth in the frequency space. So we have to make sure that we cut out room or have room for the information that we want, which is why I'm able to keep my volume of my music a little bit higher. It's because I'm cutting out the frequencies that are competing with my voice.
Okay.
And that's why it feels like it mixes well. It's because I'm not just controlling volume. I'm controlling volume at the frequency, in a frequency space.
Very interesting. So it's almost like I see there, you took out some of the lower frequencies for your application, your music.
Yes.
So I guess more bass will come from your voice rather than the music.
Yes. But you should look at the range though. So I'm doing this at
Oh.
125 and 250. And the
That's
reason
speaking range,
why
right?
is because I am boosting at 125 and 250 for my voice.
Okay.
Yeah, so we still get the bass. In fact, the perceived bass is actually higher with the music when you cut the frequencies that I cut. This is where you get into psychoacoustics, but all things are relative, right? So if
Yeah.
you hear less treble, even if the bass isn't louder, you're gonna perceive it as louder. So
Okay.
it's a little trick that you can do where you can cut frequencies to get the effect of it being louder.
Very cool.
Yeah, this is all from like audio days. It's not really that important to know, to be honest. And then here's the ducking that I was talking about. So this is how I'm able to have my music playing in the background, and when I talk, I have it duck under to be 65% of whatever it currently is.
The overlay source is heard when it meets this threshold. Okay.
I think I should be able to demonstrate this. Let me turn this on, and this could break the stream. So if it does, we'll just start over. It's fine.
Okay.
All right.
I don't hear the music anymore.
Yeah, you shouldn't.
Okay.
I had to go to Ecamm to change the input. If I can find Ecamm, I've lost it. Oh, here. Okay. All right. Cool. Okay. So let's change this from Zoom to stream. Turn on my mic. And there does seem to be audio coming through. So now I gotta just make sure. Can you hear this on the stream at all? You should hear it on the stream. Yeah. And the reason why you don't hear this in Zoom is because I'm not routing this into Zoom. In fact, I never do. Zoom is always bound to this right here. That's why I named it Zoom. So I have this virtual audio device called Zoom that I always route to Zoom. So even if I'm doing like streaming or whatever, because sometimes I am doing streaming and zooming at the same time, I don't necessarily want my Zoom audio in my stream, and I definitely don't want my stream audio in my Zoom because sometimes I may have music playing. Yeah. So if you listen to the stream, I'm going to make this very pronounced. So when I talk, you're going to hear the volume go down a lot. So I'm going to put it to like 20%, and I'm gonna stop talking and then start talking, and you should hear the audio, the music goes down. Okay. All right. So I'm talking. The audio should be up, and then when I talk, the audio should dip down underneath my voice. Are you able to hear that at all? It's a big lag. It's like, I think it's 20 or 30 seconds. Mute Zoom. Yeah. All right. At the moment, I am talking so that you can hear what the ducking sounds like. The audio that's being ducked is the audio from my music application. As you can see, I have EQ happening. I also have a little bit of gain reduction happening. And oh shit. Yeah, meet me on Ecamm. Do you hear me right now? I wouldn't do it. Go into your microphone settings, and then where it says select speaker, just select something else. Like hopefully you have other sources you can dump it to. Like I know I will normally dump it to Black Hole channel 16. Yeah. Test 1 2. All right, so you okay. So what you should hear is, well, let's see. That's right. That's right. I can hear you. I can hear you. You can't hear your audio on the stream because all right. Well, let's switch off. Let's go back to let me. All right. So we're back to normal. I hope. So I guess unmute your audio or mute it, or whatever you were doing, so you can hear me again.
I can hear you, but
Okay.
I guess through the stream. So should I hop back to Zoom?
Yeah. Hop back to Zoom. It's a long.
I hear my audio now too.
Yeah, I switched back. Yeah, we're back to how things were. All right. So while you switch back, I'm gonna keep getting this in. So we have loopback, which handles it gives me virtual audio channels. So we'll just type that. So we'll say virtual audio devices. All right. And then I have eCam. It goes to eCam from there as audio. Right, and we can delve a little bit further into this little piece here, the loopback piece, because there's more than one thing as you've seen. Right, there's loopback. I have black hole audio, and I also have audio hijack.
So what? Oh, sorry. I think the internet got slow there for a bit. Could you just repeat the last thing you said?
Yeah, sure. I was saying that now you have a very high level of how how the setup is working. We have an encoder going to the computer, and that's going straight into eCam. We also have my audio going through a interface with DSP that goes through loopback, that then goes into eCam. But I was saying that this is a simplified view of the world because I also have black hole audio channels, and I also have audio hijack, which all go in this little piece here. So loopback is like the output of those first two things.
Oh, yeah. I think that's where I'm a little hazy. Is so you're putting in that loopbox category audio hijack and black hole.
Yeah.
Okay. And what if you had to summarize, like, what purpose is that serving for you? Like, you could technically have that audio go right into eCam as well, right?
Correct.
But you're doing some processing on it, which is why I guess you have loopback in the mix, and also mixing like your audio, different audio streams in like your apps and your music.
Yes. So loopback allows me to route audio to as many devices as I want. So let's say, for instance, I have another interface, and I want the same stream to go to that interface so that I can record it. Loopback gives me that ability. Loopback is also the thing that allows me to take audio from one of my black hole devices and then route that into like a real device that I own, like a device in physical land. At the moment, I'm not using it because I'm doing all of my mixing in DSP on my device, and I'm doing that to like simplify things. Now here's the thing that I lose ducking ability. So I'm unable to have audio duck underneath my voice when I talk, when I use my UAD interface. And
Okay.
I'll show you the mixing that's happening as well here. So I think I've already shown you like this is like emulation. So it literally changes the hardware parameters so that it can physically model this device. This is a Manley Vox box. I never owned one of these. They're too expensive for me. But I did used to own a Avalon interface. Just to give you some perspective, one Avalon interface is about $3,000.
Wow.
And they typically only have one channel. So if you want 2, 3, 4 channels, you're gonna buy
Oh my God.
2, 3, or 4 of them. However, like unless you're having to do like multi-track recording, you can use a patch bay to like route different mics or whatever to that device without having to unplug it and plug in different devices.
Okay.
So this right here allows me to not have to have all of that outboard gear. I used to have a lot of outboard gear back in my studio days. It's big, heavy. You got to power it. You also have to like have a clean power supply, which is just more money. And then you deal with physics. Like there's, if you have any like imbalances in your power delivery, you get hum. Sometimes you can get noise. It's like all kinds of things. Whereas here, it's just like, software gets its own set of issues, but I don't have to worry about space and my house being a heater because they're all hot. This is a tube preamp, and tubes, they work best when they're warm, aka hot, and they burn a lot of energy. So yeah, I'm kind of glad I got rid of all that shit. But in any case, we're doing some processing here, and if I turn this on, which I forgot to turn on, you're going to hear the music change. All right, you hear the music, it went down.
Yeah.
And if I turn it up, this is what I mean by I can increase the volume of my music while still being able to hear me. It's because I've EQ'd the hell out of it. So
Wait, I'm confused.
I can increase the perceived volume of the entire stream. Like I can boost the volume of our music without having it like occlude or shadow what I'm saying. So if I were to turn this all the way up, we would be competing with the music. But because I've taken out frequencies that our voices lie in, I'm able to keep the volume of the music louder because it's not overshadowing our voice because I've cut those frequencies out. The best example is just
I guess that slider there is affecting your music volume.
Yes.
But I thought this was connected to your hardware before it even gets to your computer.
It is. There's more to it. All right, so let's go into my audio MIDI settings. All right, so one of the cool things about these UAD interfaces is that it has virtual channels. So it's virtual, just like with Black Hole, except these virtual channels have a superpower. They are routed through my UAD, so I'm able to affect them using the DSP on my device. And the way that happens is you just go into configure speakers, and what I've done is I say, yo, just route to virtual 1 and then route to virtual 2. And
so you have your computer's output being routed into the virtual slots channels on your UAD.
Right.
And how did you set that up? What exactly is what's the output that you set? Like, where'd you link up the output to the virtual channel?
So the output is not, you can't control that link. It's always to the UAD interface. So it gets summed as if it were a separate channel. So think of like your device has 4 mics. Well, if it had a virtual mic or a virtual channel, well, you still have your 4 physical, but that 5th virtual channel is still being summed along with all your other channels. So the virtual channel's output is the UAD device itself.
The virtual channel. Got it. But what's the virtual channel's input?
The virtual channel's input.
Like, where is that a hardwire connection?
No, it's not hardwired.
Yeah.
You can select it. So for me, what I did was I came into configure speakers. So under my device.
Okay.
And this right here is your just it doesn't show it, but like you should think about this as the system audio's left channel and the system audio's right channel. So what I'm saying is, where do I want that to output to? And I'm saying output to this virtual 1. And then for the right, just output to virtual 2. And when I pull that up, I'll show that. So that's here. In fact, let me unlink these. So you see that they're actually 2. But I've linked them as stereo. So we'll link it as stereo.
Oh, okay. Okay, so when you click configure speakers on that settings thing, that's like across all audio devices, right? That's not like that configure speaker is not just for.
This is system audio.
Because on the left you have Universal Audio Thunderbolt selected.
Yes. Yeah.
That's not like related to that, right?
It is related. So it's only for this particular device. So certain devices allow you to configure where the output goes. So you see my Mac Studio speakers. I can select where this goes for this particular device. Because the Mac Studio, which is my display, it only has 2 speakers. We only see these 2 speakers. However, if this had like a virtual audio or other channels, I can then select these and say, how about output it here? In fact, I can flip them if I wanted to. I can say, you know what? I want my left to play on my right channel, and I want my right to play on my left channel. Okay. So it's a little bit confusing because I mean, most audio interfaces don't have this. But like if you wanted this, you're gonna pay for it. So like just this one right here only gives me 2 virtual channels. I think the X4 gives me 2 virtual channels. If I get the X6, I think that's where it gives me like 4 virtual channels, which are really useful because it allows you to route audio from your DAW. And I should also be very careful here. This is not necessarily designed with taking audio from your system and like doing stuff. It's really designed for you to be able to route audio from your DAW, your digital audio workstation, into your UAD so that you can then apply DSP to it in real time. That's what it's really meant for. However, I know enough about how audio works in Macland because of Logic back in the day that I'm able to kind of like, do some things that are a little bit more interesting that you probably wouldn't see normal audio folks doing. So in this case, this universal audio, this is just taking anything that's system audio. There's nothing else. So if it's playing on my computer, I'm able to route that into this virtual channel and then control the amount of volume that it outputs into the total channel or into the total output mix. So let's go back to our, where is it? Here. So that's what enables me to be able to do this. Like, it's because it's literally my system audio, but I'm able to control it, the output of that here.
Nice.
But I want to be careful here as well. The input to this channel is still at 0 dB. That's not changing. The only thing that I'm changing is how much of that signal gets output by UAD. And because I'm changing that, it also affects how much gets summed into the total output.
I see. Yeah. Can we just draw out your UAD's input and outputs?
Yeah, what do you mean?
Like, okay, so let me, in Excalibur, I'll just go down a little bit.
Okay.
And try to like model what I'm thinking, I guess. So your interface, your UAD interface has, I guess, 3 things coming into it. Like, or rather 2, unless you want to count your left audio channel and your right left mic channel.
Okay, yeah. So we have a left mic channel, or just mic 1 technically, and then there's a mic 2.
Okay.
Which I'm not using now, so you can ignore that, I suppose.
Okay.
And then there's also the
system.
Yeah, the system audio, which comes in via the virtual audio channels.
Okay. And then what do you call the output here? Like, is
the outputs? There are a few. You can call the first two monitor L and R, monitor left and right.
Okay. Monitor left and right. Got it.
And then there's also the virtual channels, virtual 1 and 2.
Oh, so there's more virtual channels. Okay.
Oh, no, on the output side. These are outputs. Input channels and output channels are different.
Okay.
I think that's the confusion, is that like we refer to them as the same thing, but a channel always has an input and an output, and they're always named after themselves.
Okay.
And then the last one is a high pass, not a high pass, the HP channel, this right here. It's not high pass, but it's like for instruments essentially.
Oh, interesting. Okay.
Or another way of saying it is these are line out channels. So if I had another device, say for instance a Rodecaster, what I can do is just plug that into those two channels, and none of the things that I'm doing like mixing wise, none of those things will affect the output channel. It'll go out as is.
Oh, just like a pass through?
Yeah.
Oh, okay.
Depending. You can also change it so that it's not just a pass through with using one of these toggles here.
Oh, that's cool. Okay, that makes sense. So now you're speaking, your microphone's picking it up, passing it through the UAD. You have your system audio also going through the UAD. And then how is this getting to Zoom? What else is
okay. So Zoom
in between this and Zoom? Yeah.
That's loopback.
So then loopback is picking up that's okay. So that UAD in loopback right here is the monitor L and R. No, sorry, not monitor. I guess the virtual outputs.
Yeah. These 3 and 4 are my outputs, like the summed outputs.
Okay, but that's not monitor, right? Monitor is something else.
That's not monitor.
Okay.
Although not monitor from what you saw. It's monitor, this monitor right here. ML.
Okay.
These two.
Okay. So do these map to the channels that we're seeing in loopback? The ones that are.
Yeah. So let's look at that. So you see here we have 10 channels of input. That's the key. These are input channels. If we come to our inputs here, you see that the first two channels, we have our mic line and high Z for our first two channels, except for channel 2. We only have a mic and a line 2. Next, we have 3 and 4. These are our monitor left and monitor right channels. This is the big fader that goes to my headphones, that go to my monitors, and it's also this thing right here. That's what that controls. Next, we have our virtual channels, virtual 1 and 2, and you'll see that those are here. Right, so these are the inputs. This is what's coming into my system is here. So just to drive home the point, I can mute the audio in our stream. You won't hear this anymore. However, you still see audio happening here. So that should drive home the point that this is monitoring the input of virtual channels. There's still music playing on my Mac. You just can't hear it because I've turned down the output on the virtual channel.
Yeah. So here's where I'm confused. Okay, so in loopback, channels 1 and 2 there are piped to like channel 3 and channel 4 from UAD. Which is your monitor?
No, I'm piping the output of 3 and 4 to a new virtual channel.
Which is what Zoom is using, right?
Yes.
Okay. But 3 and 4, which are monitor, I'm assuming it's monitor based on your console settings thing there. Do they mix? Are they summing up the audio so they include system?
That is the summed audio. That is the summed audio. Yeah.
Okay. So got it. So when you kill the audio there, UAD in loopback is not showing that because that's the input.
Right.
But you're just affecting the summed output by turning that knob. Got it.
Right. So these faders here, they show the output. It seems like it's the input because when I talk, you see something, but it's really the output. If I were to turn this down, whereas if I turn it up, you see that it's coming up. So this is actually affecting output. So what you're seeing on the left and loop back is all input. On the right here in our console, this is all output. So if I jack this up, I bring in the input that was always there.
Okay, got it. That makes a lot of sense now.
Okay. Yeah, I know it's
Thank
a
you.
lot. It's
Thanks.
confusing. It's really confusing to be honest. So yeah, that's how we get from my UAD into Zoom and as well as the stream, because in Zoom I've selected my mic input source as this Zoom virtual device.
Yeah.
So whatever's being output here, you're gonna hear in Zoom, and then same for Ecamm. I'm currently using Zoom. However, sometimes I may use the monitor stream, and that's how I can get like my audio hijack session into the stream. It's just by switching the input that Zoom, or I'm sorry, that Ecamm is looking at.
Mm. Okay.
A little bit more sense, maybe.
It's click. Yeah, it's starting to click. I'm starting to get it. Yeah.
Okay, all right. So I think it's maybe useful to talk
Yeah,
a
there's
little
so many
bit
moving
about.
pieces that trying to find out the motivations for each one of them.
Yeah, and that's what I want to cover here. Like, why am I using loopback? Why am I using virtual, or what is it called? Yeah, the virtual audio channels like Black Hole, and why am I using audio hijack? So let's talk about the first one, like Black Hole audio. Uh, let's go back to thing.
Yeah, it helps me understand when it's like driven from a pain point, like because it's like, why do we need to introduce complexity? So it's like, all right, I'm trying to do this, but the simple solution doesn't work. That's why I have to add this thing or that thing, and then that helps motivate the concept, I guess.
Right. Here is the top like the main motivating problem. I would like to listen to music. I'm gonna make up a problem. I want to listen to music, but I can't play music in YouTube or in Twitch. If I have no type of audio splitting or routing, that means that I can't listen to music, because whatever I hear, the stream hears. How do I get around that? Well, the first thing is I have to stop treating my audio as one source. I need to go back one level higher and say I want the actual channels of audio. So on a system, every app can write audio to an audio stream. Every device that does audio can also do the same. So I want to be able to manually get control of the specific channels that I want and sum them together on my own terms. Black Hole audio allows me to do that. It allows me to take whatever arbitrary sources of audio and dump them into one place. And then from that one place, I can do whatever type of processing that I would like to do to it, whether that be gain reduction or some type of EQ or compression. It allows me to do that. Now, go ahead.
Yeah, it makes sense. So it gives you more fine-tuned control by giving you access to like the raw inputs, and then you can kind of compose them how you want to create different combinations of outputs.
Right. And
cool.
Also, because I'm doing this, like, because they all have like different like channels, I may have audio tools or like different plugins, like simulations that I may want to run on those audio buffers. And in order to do that, I have to have some way to hook into it. Black Hole, well, technically Black Hole doesn't give me that, but it gets me almost there. Audio hijack allows me to do that. It allows me to insert whatever I want into the tool path or into the audio path. So you're seeing it here, like you're actually seeing it like in real time. Like here's my audio input. It can also be, it can be like one of the Black Hole devices too, but it allows me to put in these types of processing in the middle of the tool path, or I'm sorry, in the signal chain, to affect my audio. So this is how I'm able to yeah, go ahead.
Quick question. Your input device here, the UAD, does that include the virtual mixed in?
Yeah, it includes whichever channels I select. So
when you say default, that includes the monitor, or is it?
Yeah,
it does include the monitor, right?
Yeah.
So that means it does have music built into it, but then you also have music down below again.
No, the default is the first two channels, 1 and 2.
Oh, okay.
Yeah.
Got it.
And the only way I can get the music, because remember these are inputs and they're all separate, is that I would have to select the input where the music is actually on. And I think in this case it'll be 3 and 4, the virtual channels.
Yeah. Well, 3 and 4 is, oh, I thought 3 and 4 is monitor. Oh, but this is just like if you,
Oh no, you're right.
yeah, 3 and 4.
Yeah, you're right.
Yeah. So that would have music. So
Oh,
then
wait,
you would hear double music if you had set it to 3 and 4.
Let's see. And we'll just run it. Nope. There's some music on 3 and 4. Let's try 5 and 6, which I would expect there to be something there. Nope. I'm gonna explain why. There's some other thing that I haven't really. So whenever you take out these, you see excluded source, I'm able to remove certain channels from system audio.
Wow.
So it's technically
cool.
not playing through the system, which is what my UAD is monitoring. Audio hijacked has hijacked that audio before it got mixed into system. And I'm able to now control it separately.
Oh.
Another reason why I like this audio hijack tool, because it gives me a lot of flexibility. And here, you know, I'm selecting the application I wanted to listen to. And because of that, the whole double audio problem that you were talking about, that's how I solved it, is I excluded from system audio. So therefore, even if there is music playing, it'll never happen here on the input side.
Wow. That's really cool.
Speaking of cool shit, like here's some even more cool stuff.
So when you drag on that system audio tile.
Which one? System audio. Here, yeah.
Yeah, sorry. Yeah, so that system audio tile, when you edit, whatever you apply there, it'll automatically feed into the virtual. It affects what's going into virtual. Like it doesn't matter what system audio is plugging into over there. Like it goes to the mixer, right? Which goes to the VU meters.
Repeat that again.
I guess what I'm saying is, okay, so system audio there, you have the tile and then you disable music from it, remove the music application from it.
Mm-hmm.
Now that's feeding into mixer and that's feeding into VU meters. And then that gets the peak. And then is that, okay, but I guess to me, it almost felt like you would need to do the system audio tile feeding back into system audio or something like that. Like you were, what am I trying to say? I guess I'm surprised that the way to modify your system audio was like, it didn't make sense to me that it didn't tie to an output.
It is tied to an output. It's tied, so system audio is tied to black hole channel 2 or 2 channel in a long roundabout way.
But I guess that, okay, here's another way of saying it. So that system audio tile almost represented to me an input.
It is an input. You're right. It is
an input.
Yeah.
But by you applying that music thing on it, it was also like the output into your
not quite
UAD.
Not quite. So what's happening here? So system audio is an input, but what you can do is you can exclude sources of audio that are going into system audio in the first place. That's what this is. So you should think of like system audio. It's like another mixer, and there's maybe dozens of apps playing audio. Exclude is equivalent to mute that particular channel where that audio is coming from, so you won't hear it on the output side of system audio.
Right.
So this is an input, except the input isn't a device, it's the system itself, which is why you don't see like something pointed into it. But the output is just that, like it's an output of whatever is coming out of system audio. But if you've excluded certain things from system audio, obviously it's not going to be able to output that on the output side. So it's effectively a mute switch.
Okay.
And
okay.
I wish that there were a way to like visually see. Actually, maybe we can. We have this visualization here. Let's try to do something. So we're going to create our system audio thingamajig. All right, oops. So we'll say system audio. And inside of system audio, we have channels. So we'll just draw a few of them. Okay, well, maybe not. Can I do that? Yeah. So we'll create a few channels.
I'll help you out.
Thank you. All right. So in this first channel, we're just gonna make up we're gonna say Safari. We're gonna have I don't know, music, and then over here we'll probably have our gosh, what do we call it? System audio or system sounds. So like like the notification noises, that kind of thing. We'll have that.
Yeah.
All right, so can I make these different colors? Okay, yeah.
Ooh.
So I'll undo. Nope, can I not undo that? Want that to be red. How do I do this? This is confusing to me. I want this to be red. Okay, so I want everything else to be green, I think. So green means that we're getting audio. All right, so
okay,
this right here these are all inputs that are coming into that are part of system audio. Now system audio is going to output as well. System audio is going to output to whatever the output card of the system is, like whatever audio output is. So we'll just say whatever audio output is. Do that. So we'll say audio out. This is a pointer to whatever you like. Right. Typically on your computer, if you're on a laptop, audio out is going to be your speakers. If you plug in external headphones, audio out will likely automatically switch to your headphones. If you connect Bluetooth speakers, audio out will change to your headphones. Or if you have an audio interface, you can say, hey, I want the audio out to be my audio interface, which is what I've done here. Now, each one of these applications here, let's also put Zoom since we have Zoom up, and let's also throw in, I don't know, let's Arc, we'll just say that. So all of the audio that's coming from these different applications, typically we'll get some together and just shoved out of the output side. Now with the exclude audio source that we're doing in audio hijack, that's effectively me saying, hey, like I know that we have all these things happening. I don't want audio from here. Turn it off. Don't output that out.
Okay.
So that's what's happening. So like I can turn off whatever I want here, which this whole thing is an input. I think that's maybe the confusing bit. Is that like it is an input, but it's an input of multiple channels. So maybe this is helpful to see that these are actually channels that make up the input system audio. And because inputs have
I think
outputs,
what confused me is like the audio out part is that like the audio out is both going to that black hole thing, but also it's going to your UAD where it's being mixed with your voice.
Oh, okay. So in here, that actually isn't happening. So whenever I do this audio isn't going to my UAD at that point. The only thing that can ever go to my UAD, well, honestly, none of this goes to the UAD. I'm only using the UAD as an input source. But note that I'm not running this, so it's hard to tell. If I were running this, it would still be the same effect, except none of this is going through the UAD. It's all happening through audio hijack and loopback together.
Okay. Along
with Ecamm, because remember each scene has its own mutes and all that, and you can select your different inputs. So like, yeah, I'm not using the UAD at all whenever I use this. I was just showing
I think I'm just gonna have to like play around with this and kind of like figure it out on my own a little bit too with my own channels. And have you ever had that issue where you get feedback because like your output's coming back in your input, and it creates like this feedback effect?
Yes, although not that often. I have a very good mental model of like the signal path because I used to do this for like, so it's like,
I think that's the advantage. I think that's what you have to get to is just understand the signal path. Like once you can figure that out, it's hard to make dumb mistakes. I'm sure it happens every now and then, but like you're not just like plugging things randomly, hoping for it to work, which
Yeah.
is what I kind of do sometimes.
Yeah, and I think this should give you a pretty decent intuition of how some of this is working. So I think one of the key insights is just understanding that system audio is technically a collection of channels. Each app has its own channel, or channels potentially, depending on what kind of application. And once you understand that fact, that gives you a lot of power to, like, if you have software available to you, like, you know, like Audio Hijack, this allows you to basically tune what's coming out of system audio. And there's actually an option here. Oops, not that. So you see here, include alert sounds. If I were to uncheck this, then any of, like, you know, when you update your volume, or if you know, put a wrong command or whatever, you won't hear those noises because we've excluded that from the thing. And that's what this corresponds to. System audio, or system sounds. I'm sorry.
System sounds. Yeah. Got it.
They call them alerts.
So I have one last question for you. This is something I actually tried to do once and I got stuck, but I wanted to create a Zoom audio device where whenever I played a YouTube video, it would come in through my microphone on Zoom. And I think that's when I initially had downloaded Loopback or Audio Hijack, I forget. My first question is, like, so I guess let me present what I thought was the solution for my problem and how I approached it, and then maybe you can like tell me if I was thinking about it the right way or the wrong way. What I wanted to do was, when I'm talking to someone on Zoom, my microphone's going to Zoom, that channel. I wanted to switch that microphone channel with a composite channel that had both my microphone and YouTube audio out. So I was like, okay, I need like a virtual device or something. So I forget if I used, when you think that, where does your head go first? Is Loopback the thing for that, or is audio?
Repeat that.
Yeah, the thing for that.
You broke up a little bit. Are you there?
Okay, so if I have, say, ignoring all the complex setup that we have, just like, say, like at a basic level, an average Joe wants to set up something where you're mixing your microphone output with YouTube's output, like your Chrome browser, I guess, output, and you want to mix it together and then present that as the microphone input to Zoom.
Okay.
Which tool is the right tool to do that compositing of the two channels?
So there are two tools. One, you can accomplish this with Black Hole Audio with some effort. Because because like it doesn't have the interfaces built for you to easily do it. You would have to, like, you'd have to actually go in and do it yourself. I would use Loopback because it gives you that interface to control stuff like that very easily. So let's go ahead and quit this because we don't need that. Let's open that. So what I would do is I would create a new virtual device, and I would delete this pass-through. I actually don't want that. And then I would come here and add the application. So YouTube is likely going to be played out of something like Firefox or something like that. Yeah. So I'll come and select Firefox. Oops, that's not Firefox. Do I not have Firefox installed? No, I do.
Oh, there it is. Okay.
So I would do that. That's the first thing. The second thing is, from my audio interface, I would select wherever my audio interface is. I'm going to select my UAD, and then I'll just route that into the same channel. And now I guess
you'd want to do 3 and 4. No, you do 1 and 2. You just want your pure mic.
Well, I'm assuming it's for you. So like you won't have all of these things. So it'll likely be your first 2 channels. And what you'll notice is that, like, because this is only showing, this is just one input. So I have a couple of options. I can do the summed channel, which is 3 and 4, or I can do this, which technically you shouldn't do, but I'm gonna do it anyway. I just double up. So I have a dual mono. So I'm pumping the same audio into both, which is fine because technically it's a mono source. However, if you use the summing on the mixer, it sounds, in my opinion, better, I think.
Okay.
So yeah, that's how I would accomplish
easy,
that.
Huh?
Yeah.
I feel like I tried that. I couldn't get it to work for some reason, but maybe I And then okay. Um and then if say I didn't okay, I think I got it. I was trying to think about how to monitor that, like just to make sure you knew the audio was
Okay.
going through.
Okay. Well, so we can do that as well. So I have two here, but let's do this. All right. So we'll delete that, and let's do arc. We'll just do arc, and then we'll also throw in audio. Let's use, where's my studio? Yeah, well, let's use my studio display. All right. And this is where I can have my different monitors. So let's say, for instance, that I have some external headphones. Well, I can say, all right, well, I want all this to go to those external headphones.
That's so cool.
And
I'm starting to see the power here.
Yeah.
I need to get loopback.
It's maybe I don't like to say people need it, but like it's, if you're trying to accomplish that type of stuff,
yeah,
it's kind of a challenge to do it without a tool to help you. And
yeah, it just makes it so easy. And
yeah.
the interface is nice. I know I'm sure there's free ways to do it, but this is just
that's why it's with effort. It's when I say effort, it's not low effort, it's like effort. And you also have to understand how core audio works to some degree. Apple's core, because I mean that's what all of these applications are using. And yeah, I only know how some of these work not because I've done core audio work in the past, but just I have been doing like audio stuff on Mac since 2004. So it's been just it's more so like observed experiences, and just like the OS has changed a little bit. So before it used to be a little bit different, and now it's very different. However, like a lot of those core concepts are the same. They haven't changed. It's just new UI to it. But yeah, like honestly, I think the best way to learn it is via someone else with this shit, because it's not obvious or straightforward.
Yeah, very cool.
Yeah. So anything else about this kind of thing? Like, I mean, we talk about sample rates. That's important.
Sample rates is important. Yeah. And then okay, so before I totally get loopback now. I'm still a little confused on audio hijack. Like, what problem is that solving?
So this only allows you to route audio to different places, loopback.
Okay.
What if you want to affect that audio in some way or in any way?
Oh, okay.
Loopback. Or what if you want to record certain bits of the audio? Let me bring it back up. Oops. All right, so I have a few things going on here. At any point, maybe I want to be able to record something. So let's say, for instance, I'm doing a stream and it has music, and I know that on YouTube, if it has music, they're going to demonetize me and probably strike my channel. Well, what I can do is I can go ahead and stream anyways and just have it where it never saves it. But here's the problem. Because Ecamm is recording the output mix, it's going to include that music with my voice. Well, if I want to just have my voice, I need some way to have just the solo version of my voice. Well, where can I get that? Well, I can use this to record just a solo version of my voice. So let's say record. So I can just drop a recorder anywhere here in this path. So I'm like, all right, let's just take it in raw. So now I'm able to record my audio.
Nice.
Yeah, and I can do this anywhere. I can do it before or after effects, or I can do like other. So you see here where it's like I'm taking a copy of this and I'm still being able to send it over here, but I can take a recording of it, which is separate from Ecamm. Ecamm does do split audio channels, but it's only split based off of the inputs that Ecamm has. So if you are recording a summed channel, there is no way for you to take, well, I mean, there is. You can use Fourier transform. You can do that, but it's like there's no easy way to take.
There's no easy way.
That music that's been mixed already out of the video. So if if I use audio hijack, I'm able to record that on the side so that when the video is done, I just mute the video's audio and I just sub it with this. So now I just get the pure voice and I don't have to worry about Google striking my channel.
Got it.
That's
It'd be cool if
one.
Ecamm had a feature where based on which platform it's outputting to, it could use a different device. And you could have a device with like without the audio mixed in or a different audio mixed in that's like copyright friendly.
There's an easier way, and I don't know why they haven't done it yet. And let me bring it over. I'm sharing my screen, right? Yeah. All right. So if I come into my settings and go into recording, you'll see here that I am able to record isolated isolated audio channels. I don't know why it doesn't say that here, but it's here, right? The problem with that is that it's isolated based off of the already summed inputs of Ecamm. Let me find. I have a lot of windows up. Give me a second to find the right one. Okay, I found it. Here we are. So you see here how like I can select different sources, but these are all effectively like your Rodecaster Pro. It's as if you plugged the output of that into Ecamm. Well, the only way that you're going to get your music out is if you didn't record it in the first place. There's no way for you to listen to it and have it playing during your stream and then not have it for your recorded video.
Yeah.
So yeah, like there isn't a good way of like being able to just get the audio that you want using this method, because it's too high of a abstraction. If this instead focused on the different channels within a input source, that would be even better. So like for instance, let's say that I selected UAD audio Thunderbolt here. It would be nicer if it did what Loopback does, which is it shows me all of my channels that I have available and it allows me to pick the one that I want. It doesn't allow me to do that. It looks like I don't have Loopback, but I can show you here. So you see how I have 10 inputs?
Yeah.
Notice how on Ecamm, it has no concept of that. It doesn't know that there are 10 inputs. It would be ideal if I could say, hey, I want you to record these inputs, like just record them all. Give me a separate audio track for each input. And then like later I can go and choose one I need. That's also wasteful though, because now I'm recording 10 times the audio that I need so that I can take the one track that I want. Whereas with hijack, it allows me to just select the one that I need, and I have full control over how it's encoded. Right, so you see here I can do it as a MP3, whether it's variable rate or not. I can also do not MP3 like AAC or lossless or AIF, which is like wave.
But when you save it down to MP3 and you want to like add that to your save down stream from what was it called?
Ecamm?
The software?
Ecamm,
yeah. You still are gonna have to sync it, right? Because like the audio, whenever you click run here, that's when it's gonna start recording from. And you're gonna have to find a marker and like sync it.
Well, you don't have to sync it manually, because remember Ecamm is recording the same audio, except it has music. So it's gonna have your voice and the music. And if you're using Final Cut Pro, you can just you can sync it automatically.
Oh, it does it automatically. That's crazy.
Well, I mean, it does it based off of because it's the same audio effectively. It's just one has
music, one doesn't have music.
Yeah. So it's synced based off of that.
Guess it. Okay.
Well, it's not even the best guess. I mean, it's very accurate. It's sample accurate actually.
Wow. That's pretty cool.
Yeah, so you don't really have to worry about it too much. But even if you did, like, I want to say that, well, I don't know if Ecamm does this, but this is where you get into like pro audio and using timecode, which is a whole other thing. I am only familiar with timecode in an audio context using different outboard gear and MIDI devices, which need to be synced to some type of clock, synchronization. You can use timecode for that. But there's also timecode in video land, which is, how do you make sure that your video and your audio are aligned with each other, but also with other cameras that may be recording the same scene. So it gets complicated, but that's what you use timecode for. There's nothing here that you need to use timecode for. You could just use Final Cut's built-in ability to do that. And I imagine Premiere does it too. I just don't know how other editors work.
Gotcha. Very cool. Okay, now I'm starting to now everything's sort of coming into coherence.
Yeah, it's a lot. It's kind of like with software engineering, right? Where it's like, or especially front end, where it's like there are all these tools, but like unless you really understand the problems, you know, it's hard.
Yeah, you're like, why do I need Webpack? Why do I need a transpiler? Why do I need like CSS and JS? Like there's so many different things, but when you have like the motivating pain points and like you start with the problem and then you see, oh, I need a solution here. That's when this comes in. Okay, now it makes sense.
Yeah. Now with that said, like if you can accomplish this without having to use all this, even better. I can get about 80% there using just my audio interface. But
oh wow,
some of the nicer things that I can't do. For instance, I can't record my audio easily using just my audio interface. I would have to open up like Logic or Ableton Live or something and just have it open in the background and also monitoring this, like where I'm talking, and just record it that way. That's too much effort for me, which is why I like having it here in this tool. But there's also things like, what happens if there's noise in your background? Right, like when you're going outside of like Zoom and using their audio stuff, maybe you want something similar. Audio Hijack gives you an easy way of doing that. They have tools to denoise, dehum, as well as like add reverb and denoising the background, all here, which is kind of cool because you can't use plugins and Ecamm, unfortunately. That would be dope if you could.
What's that switch thing doing for you?
This right here?
Yeah. So
this allows me to just do this, and if there's any audio coming through, it won't be mixed. So
okay,
this corresponds to when I'm in my countdown. I still want music to play. So
you don't want your microphone going through it, so you can quickly just turn it off like that.
Exactly. Yeah.
Okay.
Yeah. Now I can emulate this on my device by just, if I unmute, you can hear me now. So I can emulate the same behavior just by muting. So that's what that toggle is really doing. It's just a mute.
Okay.
Yeah. But what's cool about this is that it shows you your audio as it's going through the path. So you can visually see that it's muted. And also, if I don't have this open, which I don't always have it open when I'm going through Audio Hijack, I can control everything from here. So I don't have to worry about, like I need to do something here. It's like I can control volume of the mix. I can control, whether or not my mic is hot. All of that I could control from one place. So it's just another place where I can do stuff at. And yeah, you see all these audio units. These are all plugins, like audio plugins that I can put into the mix and change things however I like. So, well, I can't do it now because
have you heard of waves.net or waves.com?
Waves, the plugins?
Yeah, I bought some like audio units from them a while back.
Yeah, I used to use their stuff a long time ago.
Sir.
Wait, you're breaking up again.
Hissing kind of.
Can you hear me?
Sorry, I think my internet's a little unstable.
Are you wired in, or are you using Wi-Fi? I think I lost him.
I'm back. I think my internet's a little unstable.
Are you using Wi-Fi or are you wired in?
I'm using Wi-Fi. And I think my MacBook is closing in a clamshell by my foot. I don't have a long enough wire yet, so I have to put it there. I think it gets like bad signal down there. I noticed. So I'm trying to do a workaround for that.
This is I wouldn't even call this a pro tip. This is a must. Plug in, use Ethernet. don't use Wi-Fi for streaming.
Yeah,
It like
I hear ya.
you just can't use it. It's not reliable. In fact, yeah, it'll change your life. Like it's ridiculous how bad Wi-Fi is. So I'm plugged in, which is why I tend to not deal with issues. It's because Wi-Fi is just weird. I don't think it was meant for that.
I hear ya. Yeah, I hear ya. I think I need to figure out a solution. I'm not sure how long term I'll be where I am right now, so I'm trying to like pick the best short term solution for now. But yeah, I think
$5 cable, bro. Just get you a nice 20-foot, 30-foot cable.
definitely seems the way to.
That's what I got, a 50-foot cable, and it's so my router is over there behind my TV, and
Yeah. Oh.
I literally have an Ethernet cable, like from there to here.
Going from there to here.
Yes, it's a 50-foot.
Wow. How do you hide it? Or where is it? Is it going across the ceiling or?
No, it's going underneath my TV stand, underneath my rug, underneath my couch, and then along this long wall here. There's a wall that you can't see here, and yeah, it's going up to my Mac Studio, plugged in directly to the Mac Studio.
Wow.
And soon.
Wow. Sorry. Yeah, I apologize for this. I'm like it's cutting in and out. But yeah.
Oh no worries.
Do you have Cat 6?
Yeah.
No. Oh, nice.
Yeah.
So you're ready to go.
The route. So my router is. I'm not using the router that AT&T gave me. Like that's what gives me my internet. So I have gigabit here. And I think I think we're wired because we do have like actual plugs here, but those are Cat 5. So I'm not using that. What I'm doing is from the Cat 5 plug in the wall to my router. My router is using the latest stuff. So everything that's connected to the router is faster because my internet speed like that's not going to get faster. It's gigabit. And in fact, I can actually show you that. Like I actually reach gigabit most days. Let's see, fast.com.
Whoa.
Yeah, so like I'm getting like 920 right now, and that's with me
snap.
streaming and shit happening. So it's just like, like even if like my wall were 6, it wouldn't make a difference because at the end of the day, like my bandwidth is only a gigabit. However, all of the devices that are connected to that router, either physically or via Wi-Fi, those are fast as fuck. So like my laptop is, it's Wi-Fi, but I can plug in as well. But I can access this machine at full bandwidth of the Wi-Fi on my MacBook Pro. Vice versa with like all these other things. But yeah, I actually have a NAS that I need to set up. Like it's sitting here. I just haven't. I haven't put it up. It has a 10G.
I have one set up. I have like I think 32 terabytes on there.
Oh shit. RAID 0, RAID 5, or are you doing like a mix?
I did I think I have RAID 5.
Which one do you have? Did you have a Synology or something else?
I got the Synology.
Okay.
Synology DS920.
DS920. Okay. I think
I got
that's
it
similar.
like Black Friday sale a couple of years ago.
How do you like it?
I love it.
Love it. Okay.
I think it's really easy to use. Synology's like OS is really nice. I store like a bunch of crap on there, and yeah, they have like a web portal too. You can log in remotely if you want to.
I saw that. Yeah. So I'm hoping to replace Google Drive and Dropbox with that. I pay too much money to all these different places. Like I have photos on Lightroom. I'm paying Apple for iCloud storage, and then I have Dropbox and Drive. I'm just like, I kind of want to take all my stuff off of these services and just have it. And
my thing is like I don't want to be a DevOps engineer all the time, so I don't know if I trust myself to keep my stuff safe. Like if something happens in my house, I would lose all of it. Yeah, you have to set up remote backups. Like they say, have one backup on site and then a third one like off site if you really want to be safe about it. So I don't have that set up yet. So nothing in there is like too important, just like movies and stuff.
Mm-hmm.
But at some point I want to get that all set up.
Yeah, that's what I want. And I'm in the same boat. Like I really wouldn't want to do any of it myself. However, if it's relatively easy, or if I can kind of go halfway, which is what I think I'm gonna do. So I'm not going to cancel all of my cloud subscriptions. I'll probably just cancel 2 and keep Dropbox or something. 'Cause I think I get like 4 terabytes with them, and the things that matter will just get backed up to Dropbox. When I think that this is easy to do because you can create separate volumes with Synology.
Yeah.
So yeah, that's yeah. So that's kind of what I'm hoping. It's like I'll just put my photos and videos, not movies, like videos that I've done or footage, so I can throw it on that, and it'll automatically back up for me. Yeah,
it's got really nice like user system, so you can have like different people can access different parts of the drive too. You can even have Docker running on there, which is kind of cool. So you can just have like a container that runs and maybe runs a daemon or a script that you want to have run.
Yeah, I've seen people running like Plex and other software on it, and we should probably do that. It sounds like you've done this. I was gonna have to learn all this from scratch. So it's like maybe when I eventually get my act together and go buy some hard drives, then we could do that. Like
I shoved some hard drives. Like it was cheaper to buy the external enclosure and then break it open and get the hard drive out.
Seriously?
Yeah, it's like there's like a whole thing. It's called shucking. It's like a whole thing where it's like it's so much cheaper to get the hard drive in an external enclosure than just get it like just the hardware part of it.
That's insane. Dang. Well,
yeah.
That's
happy to walk you through it. I hope I remember most of it. Like a lot of it was fire and forget. I did it 2 years ago, but I can always like reference my own config and like share. And I think I get the big picture stuff too. I also like was at one point I set up NordVPN. I use that VPN, but I use that. So I have transmission running on there for torrents and stuff, and it was being like piped through Nord, so I could like whenever I was seeding or doing anything on there, it was just going through the VPN. So you can kind of configure which internet it's using or which VPN.
Okay, that's good to know. Yeah, that's actually cool because like technically I have like my own infrastructure stuff where at some point I was supposed to lock it down so that only if you are logged into my VPN could you use it, and then I just never got around to it. I was just like I can just use workspaces permissions to do some of this and just keep stuff there. That's one of the reasons why I just pay for Drive. But yeah, I don't know how long I want to do that. Plus it's just cool. Like I have this concept that like I need to have an excuse for content. So from my mind, it's just like, it gives me something to stream, because as I talked to you yesterday about, it's like I often don't have any plans or goals. It's just like I just need to stream. So having reasons to like do stuff on stream is useful for me. So yeah, like learning how to do all that would be pretty interesting. So I have a question about you seem to understand audio. I think at least the path, the routing path. How about other things around audio, like the mixing or maybe video or keeping things in sync with your video? Because maybe you're recording from a sound source, but then you are recording from another video source which aren't matched. So like you need to make sure your audio is, it's matching. I'm sure you've seen old school movies where it's like their lips are moving, but it doesn't match the audio.
Yeah, I mean, I think the extent of syncing is
Oh, you're breaking up again.
Maybe I'm playing a video and I'm like the audio is now really off. Oh, sorry. How's this now?
Yeah, you're good. You're good.
Better. Yeah, I've just noticed the syncing issues with. I haven't done too much crazy stuff recording my own audio where the syncing was happening, but I know when I've like downloaded a movie or something and watched it, like as I get deeper into the movie, I feel like the stray happening, the time shift magnifying. I guess the time step is off, and then I guess you can use FFmpeg to do some of that, like audio syncing fixes, but yeah, I don't know. I haven't went too down into that rabbit hole, the syncing one.
Yeah,
fortunately I haven't had to.
It's easy if you solve it at the source. So I don't have a solution for you if like you're trying to correct it from somewhere else, but like you can delay your video or your audio a few milliseconds so that when it actually does get mixed, it's in time. And it's all based on the amount of latency. So that's that where it comes in again. So
latency.
If let's say for instance, if I were using CPU bound plugins, like if I'm using audio hijack, that's CPU bound at that point. Every plugin I add has the potential to add latency because you only get a certain amount of samples. It's typically whatever your buffer is. So let's say you have your buffer set to 512 samples, or yeah, we'll just say 512 samples. That's how many samples your plugin has to actually compute its result and then give like in basically like output that buffer of samples. So if you think about the clock rate, well, if you're doing 48 kilohertz and you were trying to shift and you need to do everything within 512 samples, well, remember 48 kilohertz is 48,000 samples a second. So like that gives you the amount of time that you need in order to finish the processing for that particular buffer of samples. If it doesn't happen in time, it just gets thrown out, and you probably heard this in like clicks or pops or that sound that you'll sometimes get.
Okay.
And there are other issues where, depending on the kind of audio plugin you're using, it can also cause a shift, although it shouldn't happen. Most plugins, most audio drivers give the plugin a certain amount of time to give an output, otherwise it just goes on about its business. But I think there are certain situations where it can actually add latency, but I can't give an example of that, unfortunately.
Okay. Yeah, I think I did notice the noise when I had a crazy setup in sound source for audio. Like I was doing equalizing, pitch shifting real time and a bunch of stuff. And then I noticed like some issues there.
Like it's like these pops and it just sounds weird. And sometimes it'll like cause your system to stutter out and all that kind of stuff. Yeah, that's all based on your buffer, the size of your buffer. So if you've ever seen that where it's like 64 samples, 128 samples, 256, it's typically in powers of 2. That's what that's referring to. It's how much time does the computer get, or like how much time do you get to finish processing? So the more samples, the higher the latency. So ideally you want it to be 0 samples, but you know, we live in real world, so it can't be 0 samples. It has to be some amount. So the lower the better. Now with that being said, the smaller those samples are, the more powerful, I guess, the faster you have to compute those results, which is just more strain. Okay. So if you're using your CPU, like on your computer, that is going to cause more CPU usage to a point. This is why having DSP is really useful, because these are like, they're not general purpose processors. They are meant for one specific thing, and they're really fast at that particular thing. And we can offload all of that type of processing, which the CPU is honestly not that good at. We could offload that to this DSP. So now we get more system resources to do what the system should do, like render your UI or respond to user input, that kind of stuff.
Okay. Yeah, that makes a lot of sense. Yeah. Have you ever had syncing issues when you were streaming in the past?
Yeah. I've solved that. Let me open up settings.
Yeah, I'm curious, how'd you debug it? What you found to be the problem, and then how you fixed it?
So the way I debug everything is, or before I started, like I would record, literally just record a couple minutes, and then I'll watch to see what it looks like, and I'll notice, oh, my audio is off. Like, and I'm talking about timing. I'm not talking about the sound. I'm talking about just timing now. And typically you can look, like you can see when you say a word and like when you hear the word, that'll tell you whether the delay is in the positive or the negative direction. Yeah. And based on that, I just came in and put in a delay. So I actually had delay here. It used to be 2 milliseconds. It's at 0 now for a reason. And it's a pretty cool reason. So your computer doesn't really care. Like I shouldn't say your computer. Syncing doesn't really care where it's out of step at. So I can fix it here at the source. But one thing that I noticed is that I could also just change the buffer on my audio card to introduce the same latency. So I did that.
Oh, wow. Okay. So what's the pros and cons of that?
I mean, honestly, the only con I can think of is that if someone else were to come to this system and try to figure out what's going on, they are unlikely to think, oh, I can just change the buffer size to introduce a little bit of latency. This is one of those things where it's like, when you truly understand how this shit works, you can start to hack it. Where that's what this is.
You're a true senior engineer, leaving
Uh,
things behind that juniors would be confused by.
I mean, yeah, I guess you
Okay.
could call this engineering if you want. But here, let me pull up my console. Show that. All right.
So you changed the audio buffer size. Interesting.
Mm-hmm. For some reason, they just call it delay compensation, but this is technically your buffer size. So initially, it was on short, which, for one thing, it basically causes my. Let me pull this up. Let me pull up the other one. Or is it not console? Well, hopefully you can see this little thing here. I can zoom in actually.
I can see it.
Oh, you can? Okay. All right. So this first thing is my DSP. That's the amount of resources I'm currently utilizing on this particular DSP chip.
Oh, wow.
Well,
It's almost maxed out.
exactly. So if I were to put this on short, chances are it's going to complain and say you can't do this because it's not enough processing. Like, there's not enough cores available to actually process this in time. Well, part of that is just like, okay, well, I'll just put it to medium. But a side effect of that is there's additional latency. If we did the math, I think it'll come out to about 2 milliseconds, somewhere in that range.
Okay.
So it's like, just knowing this fact, I mean, I can count samples. It says 48 kilohertz right there. I know what that means. So it's like, you can do the math to figure out how many milliseconds that is in latency. I don't think they want to show that.
So walk me through the math. Like, how would you do the math?
I'm not going to walk you through it. We're gonna chat GPT it.
Okay.
I think. Hold on. Let's see. We use 4 too. Wait, is this 4?
Is it what?
Like, is this 4? It doesn't give me the chance. Oh, I had to renew. God damn it. All right, I'll do that later. All right, anyway, so how do you calculate the number of milliseconds in 512 samples given a 48 kilohertz sample rate? All right, so we have the thing we know, and the other thing is the 512. So we know that 1 over the sample rate is how we get the actual time, for that.
Yeah.
And then because we're in the right amount of units, we can then multiply that, I think, our 512 here. That's where we get our units. And then we see number of milliseconds is 512 samples is equal to whatever that is. And then it says it gives you the number of milliseconds. Okay, so tell me the number of milliseconds.
I'm surprised it didn't do the actual math.
It's because I haven't renewed yet. It wants me to renew and give them money. Then they'll tell me things.
Clever.
Oh, it's 10 milliseconds. I was way the fuck off. Okay. Oh wait, no, for 512. Okay, never mind. That's for 512. What is it for 256 and 128 samples? Okay, I don't really give a shit. Just like give me.
Oh my god.
Oh,
Would
I wasn't wrong.
Divided by 2.
Yes, it is. That looks to be the pattern. Yeah. So I wasn't wrong. Okay, so it is about 2 milliseconds. It's 2.6 milliseconds for me. Yeah. So just knowing this little factoid, you can effectively use your audio buffer to introduce latency. Now you may be wondering, like, why would you ever do that? Well, there used to be a point in my life when I didn't have Ecamm, and the tool that I used didn't have a way for me to delay anything. So instead of being limited by this tool, it's like, no, I'm going to do what I want. So I did it on the buffer side.
Oh, interesting.
Yeah. But
So
it's little stuff like that where it's like, like unless you really, really start to like really get into the weeds, like you likely wouldn't think to, introduce latency by changing your buffer.
is 2 milliseconds noticeable?
No.
Okay.
However, 10 milliseconds can be. It depends. It really depends. All right. So for monitoring yourself for voice, you want the lowest amount of latency possible.
Yeah.
Because you can hear it. If you're playing an instrument like a synth or a bass or whatever, if you're listening back to it, you want as little latency as possible because it's time, right? So you will be able to, if you're really, really in tune with what you're doing, like you will notice it. And honestly, like some recording artists, they just get used to it. Like, just a small amount is okay. However, when you start getting into like 10 milliseconds, it becomes very obvious. Even to me, even if I'm not like, even if I'm on like an instrument, like I can press the key and most people will be like, I hear it immediately. But it's like, when sometimes you'll do something and it doesn't happen right exactly when you do it, you start to get that feeling. And at 512, it's like that's the max that I can tolerate. Anything past that, it becomes difficult to deal with.
Got it.
For me, right? But I mean, you can get used to anything, I suppose.
Sure, yeah.
Now, if you're trying to track with music, so most artists, they're not singing in a vacuum or rapping in a vacuum. It's typically they hear the music and they need to, like, it's always on time. You need to be on time. At that point, I wouldn't even go above 128 samples. If I could get
You
away
would go
with it.
above.
I wouldn't even go above that if I could get away with it.
Yeah.
Most devices can go down to about 64 or 32 samples. But like, remember that whole thing. Like, if you have any plugins, what you're effectively saying is, hey, plugin, you have 5.3 milliseconds to take this buffer of this many samples, and then do whatever processing you need to do on it, and then give me back an output. And oh, by the way, you need to do that literally every 5.3 milliseconds. So it's kind of like with gaming, I suppose, or I guess with animation, like we have a frame rate where it's typically 60 and we need it to be done in that amount of time. Well, we have a sample rate. That's our frame rate in audio, sample rate.
It's crazy how in video, it's like, 60 frames per second is pretty good. Here we have 48,000 for the audio.
Well, these are like samples. These are samples. It's a little bit different. It actually is not. It's very different. Here, we can use that thing that we were working in earlier. A second. We're going to see what kind of things we can do in Excalibur. Can I draw like I want to draw like a sinusoidal wave. Can I do that here?
Oh boy. There might be like a pencil tool. Yeah. You see next to the A?
The A? Yeah, okay. Let me draw a line first. So we'll draw a line going up and then a line. Okay, that's not what I wanted to do. I don't like that it gets rid of my tool that I've selected. Like, just let me.
Oh, there's a way to fix that. I forget how I did it.
Okay, so you said this, and then how do I do this?
You just have to, like.
Oh, I have to actually draw. Okay, all right, fine. We can
draw
do
it. Yeah. I don't think you can do sine waves.
Oh gosh, this is gonna be hard. Give me a second. Okay, so let's make this my 0. Actually, we can make this other one a 0 too. We'll make this our 0.
By the way, do you see that lock icon?
A lock icon.
All the way on the left of that toolbar. That will stop the tool changing thing that is happening for you.
Perfect. Okay. All right. So we're going to sine starts at 0, right? Or is that cosine? I think this is
sine starts at 0, cosine's at 1.
Okay. So we'll do this.
Still remember that.
We'll do that. Okay. All right. So this is technically, let's pretend this is a continuous function or a continuous line. But in our little digital world, we can't do this. we don't have continuous stuff. We have to take discrete samples. All right, so that's what our sample rate is really measuring. It's how many samples, and let's just make some samples. So we'll have a sample here, a sample here, sample here. I'm trying to make sure the space is relatively the same. I'm getting a little bit narrower, my bad. All right, so at each sample, let's do a little thingamajig. Oops, sorry, delete that. So each one of these samples is a value, right?
Yes.
And because the sample rate is not high enough at the moment, we can't reconstruct this wave if we wanted to. So the computer will see it like this. Oh wait, maybe I'll do a strong wave like that, and this. And notice that this estimation is not accurate. So in order to get a more accurate estimation of this continuous function, we have to have more slices.
Yes.
Or more samples. So with audio, what we're really doing is every 48,000, I guess 1/48,000ths of a second, each one of those points, we're taking a measurement of what the amplitude is.
That's just amazing to me. Like, it's that much readings in a second, 48,000.
Yes. Although I will say that it sounds like a lot, but the video is much more, because it's not just of amplitude. It's also of color channels, which, by the way, we have at minimum 3. And how many bits do you need to represent a color? And also, when you look at your frame rate, you're doing 30 frames per second, but you still have to read the sensor, which is a square. It's a square of something. So
the resolution of the video is huge too.
Yes.
All those pixels, 3 channels for each pixel.
Yes.
And like 256 bits, I guess, per channel. Like, that's a lot.
And it's doing that too. It's at a specific sample rate. In fact, not only does video include the sample rate of your video, it includes the sample rate of your audio. Typically 48 kilohertz. So your camera is also recording at 48 kilohertz.
That's true. Technology like blows my mind still. Like, I'm just impressed how powerful computers are and how precise.
Yeah, I mean, they're fast. I think that's what it is. They're able to do the same task millions of times a second, sometimes even billions of times a second, which is it allows us to do all these interesting things. But then you get into like, it's fast, but then it typically doesn't grow at the same scale as certain tasks. Video is a good one. I'm sure you've noticed that with Apple, like, they do a lot of video centric stuff and they seem to always push video. I think a lot of people just don't understand or take for granted how difficult video is. Like, if a system can perform well with video, typically it can perform well with a lot of other things, just due to the nature of video, right? Because it's so much data. So there's multiple things that, like, within audio or digital audio, that are important to note. What we were kind of covering is like your sample rate, but there's also something called your bit depth, like that. Some of the common ones that you may have heard of is 8-bit. So if you ever listen to sound on your super 8-bit. If you ever listen to CD or MP3s, you're likely listening to 16-bit audio. And if you have ever done any professional audio, you're likely experienced with 24-bit audio, right? So amount of bits, what does this really represent? A lot of folks think it's, I guess, like bandwidth, and I guess you could technically see it that way. But what I like to say is that with higher bit depths, you get to represent quieter sounds, not necessarily louder sounds, which I think a lot of people, they'll think that because the number gets bigger. But what you shouldn't think of the number getting bigger, you should think of you have more possible values that a particular amplitude can be.
Yeah, the way I like to think about it is like, in the most simple case, you have 1 bit, which is either on or off.
Mm-hmm.
So imagine listening to audio where you could only tell the computer yes or no. It would just be like it'd be Morse code literally.
Mm-hmm.
And then if you go, the more bits you add, the more nuance you get, the more you can differentiate between like low sounds and really low sounds.
Well,
And
when you
that
say
gives you-
low, what do you mean? Like low in amplitude, volume, or low in frequency? Because they're different.
I mean, that's an interesting point. Well, you're trying to represent the sine wave, and there's something interesting here. Like, how do you represent frequency versus how do you represent amplitude? Like, I can tell the amplitude means the volume, right? So like, the higher the sine wave goes, the more louder it's gonna be.
Mm-hmm.
And I guess the faster it goes at certain points, that's the frequency.
Yeah, it's the frequency is from every point of these, like, so this whole thing is 1F, like I'm gonna call it frequency, 1 hertz.
1 hertz.
Yeah, so pretend that this is over a second. If this is over a second, then that means that we have 1, 2, 3, 4, 5, 6, 7, 8 samples.
Yeah.
So that would be a sample rate or whatever that is. I can't do math right now. All right. And then because we have amplitudes, that's what the y-axis is. If we were to have just 1 bit, the way that we would represent that is, well, if it's greater than 0, then it's on. And if it's less than 0, then it's off. It doesn't matter like where along this path it is. It's just interpreted as a 1 because that's the max amount of fidelity that we have to represent things, is on or off. However, if we add that second bit, now we can we have 4 different values. So let's say we put 2 above and 2 beneath. Well, now we get to do the same thing, except now we have 2 different I guess places where we can put things, which gives us 4 possible values.
So so is the answer to your question volume?
Yeah,
it affects volume.
Yeah. So yeah, it's all about volume, and that's what bit depth is. But your sample rate, the reason why we have sample rates, the most popular one is 44.1 kilohertz. The next one is 48,000. There's the Nyquist theorem. I think let's see if I can spell his name correctly. Nyquist. Is it theory? Essentially, he states that whatever the highest frequency you like to capture, you have to record at twice that sample rate. See if we can find the Wikipedia for that. I'm sorry, it's all ugly here.
It's all good.
I can't tolerate that. I have a plugin that allows me to not look at it that way. All right. So, where is it at? Build a signal processing. Yeah, so it establishes a sufficient condition for a sample rate that allows you to capture frequencies up to a certain rate. So
got it.
If you need to capture human hearing, which is typically 20 hertz to 20,000 hertz. I'm sorry, 20,000. Yeah, 20,000 hertz. Well, you need to be able to, you have to record at double. You have to take double the amount of samples to represent that.
Oh.
And I think you can see that intuitively when I come back to here. Notice how, remember I said that one period is you go up, you have to cross the 0, you have to come back to the 0.
Yes.
So that's where the doubling comes from, because we have to account for the fact that it goes, I'm gonna call it negative, it goes negative and goes 0. So that whole thing, so you double it.
Okay, that makes intuitive sense.
Yeah. So that's why these sound like they're not made up. It's based on, most of the time we want to be able to represent frequencies up to a certain amount.
But so the thing is, like, when people talk about 8-bit audio, you just said that the bits affect the volume.
Mm-hmm.
You don't necessarily associate 8-bit audio with like a unique volume characteristic. You associate it with like its sound, like that computer retro sound.
Mm-hmm.
So how does that reconcile?
The instruments being used.
Yeah.
In fact, here, maybe I can we can demonstrate this actually. Let me pull up Ableton Live. So I have a plugin that allows me to do bit crushing, which is taking something that's at a higher bit depth and then reduce it. All right, so what we'll do is we'll use my voice. We'll try that. Let's go to an audio effect. Okay, interesting. I wonder if these are on my laptop. This is the issue with having more than one computer. All right, let's see if I can do it with this. Maybe we can accomplish it with here. No. Can't accomplish it with this. Damn it. Okay, so I don't have the plugins on this machine.
Okay, no worries.
Although I think I should be able to use this one, this retro color, maybe. I think it has a bit reducer in there. Noise to yeah. Here we are, digital. Cool. So we'll turn that.
There's one called Redux. Apparently, I googled, and that can do bit crushing.
Redux. Why are they doing
that's the name? That's the name of the plugin. It says it's kind of confusing that it's named that.
Put this back at 0. All right. So you see what's happening to this waveform? So it's really, really smooth here. However, as I increase this, it becomes more jaggy. And note that the peaks also get lower. Notice that?
Oh yeah, they do.
And that's the volume.
Whoa, that's interesting.
So like,
but now that makes sense based on what you were saying.
I think it's also, even though I said that this is volume, it's one of the other takeaways of this is that yes, it is volume, but let's say that we can only represent 2 volumes, right? So right now this isn't doing a good job of that. Can I delete these? Okay, all right, I guess I'll just write over it with another color. Hopefully that's not as confusing. So let's say that I only have 2 volumes that I can represent stuff at. Okay. 1 and 0. Well, when I come to here, this volume, let's just keep it straight. Nope. How do I undo? Give me a second. All right, so all right, so let's say this top volume, that's the only volume that I can represent. So this dot is going to be interpreted as this green line. All right, and then at this next sample, this dot is going to be interpreted at that green line.
Yeah.
And then when I get here, this dot is going to be interpreted at this green line. When I get down here, because it's negative, it's going to be interpreted at this line, that green line, this green line, and this green line. Yeah. Well, what have you effectively done? You've effectively compressed.
You're playing at maximum volume and then minimum volume.
Yes, and because of that, like, you don't get nuance in sound. Like, a lot of the nuance that you get is in the volume. So it's effectively a compression because you only have 2 values. So like the max distance between them is only, whatever that is, the sum of them. It's the max distance between them. Whereas if you have more than one value, like, you get to represent more frequencies. Because, like, remember, this is, you can almost interpret this as just like the same frequency. Whereas if you come here, it's the same frequency. There's no difference between your low and your high. So when you get into like bit reduction, yes, it's going to change the sound, the timbre. But like, I think it's also important to keep in mind that amplitude and frequency are related. Even though they're different, they are related. They have an inherent relationship. One of the other things that I didn't really touch on is that the amount of energy in higher frequencies is higher than in lower frequencies. So the flip side of that is, let's say you have something, you're going to perceive the volume change when you increase a frequency to a certain tone. However, there's the same amount of energy in there. The energy has to be maintained. So something has to change. Either the volume has to go down or the frequency has to go up to maintain the energy. I think it may be helpful if I do a signal generator here. Let's throw a operator on, I guess. Can you hear that?
Yeah.
Okay. All right. And I'm also going to put an oscilloscope on here. Oops. Maybe I should go to my plugins. Not playing? Why is it not working? All right. So give me a second. I think I'm going to have to do something silly to get this to work. Oh, my bad. I'm sorry. I just realized that I have to.
I can turn it down on my end.
Oh, it's not. It wasn't that. I'm not even recording the right thing.
Oh.
Yeah, I had to record both of these. All right, there we are. So now I can put my vision, which was on the wrong thing, on the right thing. And we'll delete that. All right, so now we should be able to see audio coming through. That's why that was the issue.
That's sick.
So what I'm gonna do is go ahead and record, and I'm gonna do another one. All right, cool. That should be good enough. And the only reason why I'm doing that is so that we can then loop it and look at it in the oscilloscope. Oops, wrong thing. All right, so let's play that. All right, so what you should have noticed is that the frequency went up. We started at like this 400, 500 range, and we went up slightly. All right, we can go to another visualization of here. For some reason, it's not showing. Oh, here, no, that's my bad. Okay, so what we want to do is a spectrum. Oops, I keep going to the wrong thing. I keep thinking it's tab. It's in here. I hope it's still there. All right. All right. So why are we looking at this frequency thing? In fact, let's look at a different one. Where's the waveform? Quick waveform. All right, so here's our waveform. Let's look into it. Is it gonna let me zoom in, or is it just gonna, here we are. All right, so you see this is what that particular frequency looks like. We have starting here, and we go beneath the 0 line, and then we come back up. So that's one period, one frequency. And you'll notice that they're all the same. They're all the same. But if we zoom in even closer, you'll see that it's kind of these jaggies. Can you see that at all? Or
it's very faint, but I can kind of see it.
See if I can zoom in. All right, see how it's kind of jaggy? It's not 100% smooth.
Yeah.
I put it in the stream. You won't. I don't think you'll see it in.
Oh, okay.
Yeah.
Let me switch over.
I zoomed in just a little bit for you.
Got it. Yeah, I see it in the stream.
All right.
Yeah, it's jaggedy. Now I can see it.
Yes. So that right there is actually fluctuations in the amplitude. That gives us timbre. So like that's why 8-bit audio has a certain kind of sound. It's because like there's less, I don't want to say frequencies that you can represent, but it's something very similar to it, because remember, frequency is you get to your amplitude and you go back. Or if you're going to the same place, then like there's a limit to how much frequency you're going to get, I suppose. Let's run this through the bit crusher that we were looking at earlier. Wait, why is it under Excite Audio now? Oh, okay, I'm dumb. Okay, man, I feel dumb now. I had a filter on there. I'm like, how is this possible? I kind of want to have both of these up at one time, so we're gonna kind of move these off to another window. And let's just say, okay, I'm okay with that. All right, cool. So now we're going to be able to like see all of our stuff at one time, hopefully. All right. Let's just duplicate this. So it's just going to keep playing.
You're zoomed in, by the way, on stream.
I am. All right, let me zoom back out. All right, so you should hear like some staticky, some vinyl noise. I'm gonna turn it up. You hear that?
Yeah.
Every time I play? All right, cool. So I also want to make sure that I'm playing this. Oh, I forget. It only, man, that's one thing I don't like about this in this mode. It only will show stuff. Oh wait, no, listen. Oh, never mind. Yeah, it only shows stuff when you record it, and it freaking pisses me off. I don't like that. Or when you play it this way. All right, so let's turn off the noise. We don't want any of that. And we only want digital, which is our bitrate reduction. And for this to really drive home the point, I'm going to have to record some actual audio that has, I guess, texture or timbre or whatever to it. So let's do in, and we're going to record me. That's not what I wanted. All right, this is a test to show off what bit reduction is going to do to a human voice, specifically my voice. All right, this is a test. So you can hear that, right? Show off what?
Yes.
Okay, all right. So let's go ahead and do some of this on here. So we're gonna go 50%.
By the way, that RC20 panel, like where is that coming from? What software is that?
This is RC20. That's the name of it, RC20.
Okay, and it's just like, it's like a audio unit.
Yeah, they have an audio unit version too. VST plugin, audio unit, as well as I think AAU or AAX for Pro Tools.
Okay,
for all the major things. All right, so let's run this and see what it sounds like. All right, this is a test to show off what bit reduction is going to do. All right, so you see how it made it sound different?
Yeah, like old time radio.
And what?
With a lot of noise.
Why the hell isn't this working? Is it doing it again? Let me get rid of it and put it back in. There might be an update that I need to do for this. It used to work flawlessly and now it doesn't anymore. All right, this is a test to show off what bit reduction is going to do to a human voice. All right, so you notice how we had to look at both actually, so we'll keep going. This is a test to show off what bit reduction is going to do to a human voice. All right, what I'm going to do is I want to change this so that as I move this, it's going to change the amount of bit reduction that's happening. So let's go ahead and find that. Is it space digi filter low? I forgot what it is, so we're just gonna have to open it and look at it. Okay, so it's whatever that is. I don't know what this is. Amount. Okay. Well, for now, let's just keep it as it is, and let's increase the amount to 75 and see what that does to the audio waveform.
Alright, this is a test to show off what bit reduction is going to do to a human voice.
All right, so I want you to notice how this becomes flatter. Are you able to see that? It's less nuance. I'll do it one more time, except this time we're gonna go full. We're gonna go full send. Let's make this smaller. Doesn't need to be that big. All right, so we're gonna make this 100%.
Alright, this is a test to show off what bit reduction is going to do to a human.
Notice that everything is almost the same volume. There isn't it's not a lot of spread in the amount of volume, so it's all amplitude. And I'm gonna keep doing it, but I'm gonna slowly back it off, and you'll be able to really hear it. I'm gonna also turn off the EQ.
You know, here's another way of thinking about it: is like if you go back to that sine graph that you were drawing, to maintain the average volume, you have to bring down that activation. So that green line has to come down, because when you had more frequencies, you're able to go to maintain the area under the curve, you have to kind of bring down the volume. That's why the volume kind of goes down when you have lower bits.
I think I understand what you're saying. I would interpret it as the amount of energy has to remain constant.
The amount of energy has to remain.
And I guess that is the area under the curve. This is where we get outside of my realm. Like, I'm not sure. But that could be the case. I wonder if we can ask ChatGPT that. Oh, for what it's worth, I just realized that someone else is watching. What's up, Kyle? How you doing? Yeah, just hanging out. The movie thing. Yeah, we're doing some audio stuff, just FYI. I was just, going over the other things that I do. Yeah, like, I think that it's worth hearing what this sounds like as I slowly back it off. And I think it'll become a little more evident, like, what reducing your bit rate is doing. So we'll play it.
This is a test to show off what bit reduction is going to do to a universe specific number.
Maybe it should loop. I thought I had it on loop. Maybe I didn't.
Alright, this is a test to show off what bit. Alright, this is a test to show off what bit. Alright, this is a test to show off what bit. Alright, this is a test to show off what bit. Alright, this is a test to show off what bit. Alright, this is a test to show off what bit. Alright, so this is a test to show off.
What's the intuition behind the noise?
The noise?
Yeah, why does the noise come in? The staticky noise.
It's noise to us, but it's really distortion.
Got it. Is it like the low frequencies kind of get flattened out and then it becomes kind of the staticky noise?
Well, think about it this way. If you only have 16 frequencies that you can represent something, well, by definition, more of those frequencies are going to be equal because there are only 16 different bins that you put it in. So that's what you're hearing. It's that fact right there. It's that
but it's not 16 frequencies. It'd be 16 volume levels.
Yeah. I'm sorry. Yeah. Volume levels.
Okay.
Yeah. The green line. So you only have that many things that it can be. So that's where your distortion is coming from, and it's going to sound like noise.
Got it. Yeah. Okay, that's what I was kind of figuring. Got it.
Yeah, and honestly, like, there's a reason why you would use stuff like that. Like, typically, if you're using like a sub bass, for instance, it's not a lot of I mean, it's just a sine wave. There's nothing there. However, when you start adding distortion or which saturation, stuff like that, even harmonics or even odd harmonics, you get really cool timbres that can happen. And I would show, can I show that? I'm looking to see if this has any type of saturation, because all right, so here's what I'll do. So
just a heads up, I might have to drop off in like 5-10 minutes.
Oh dude, how about this? We can continue this another day. Like, no reason why we have to, do everything today. So
this is so cool though. I love seeing you like use your tools, because you can explain the point so well by like, throwing up an oscilloscope, a spectrometer, and get to really like learn at an intuitive level what this sound stuff really is.
Yeah, it's a rabbit hole. Oh wait, hold on. We have a question. Isn't it the peak/low of the range change? What do you mean, Kyle?
I guess when we were talking about the distortion and the static, I think they're saying something similar to that.
I'm gonna say I'm not sure right now, but maybe I am sure, and I'll let you know. I have access to Kyle. I can reach out to him at any point.
Okay.
But yeah, like I'm not sure if I truly understand what you're asking at the moment, but this won't be the last one. I'm happy to do more of these, more audio, even more video stuff. Okay.
Yeah, this was really cool. I like learned so much. I'm like itching to now download Loopback and play around with it a little bit.
You should. I highly recommend it. Well, before I say I highly recommend it, it depends. What are you trying to accomplish, right? If you're trying to have audio similar to this, I would say that's the easiest way. No, it's the second easiest way. The easiest way to do it is if you just download Ecamm. you can install the system audio plugin, and it'll automatically mix your system audio into your stream. That's the easiest.
Okay.
And if you do it that way, then you would just control the volume of individual apps from within the app itself. Here's where that problem, this is another problem on Mac OS only. Mac OS does not have a channel mixer per app like Windows. You know, in their audio settings, how like you open it, it has a per app audio change. Mac OS doesn't have that. So a lot of what I've done is because Mac OS just doesn't have simple shit that Windows has had since Windows fucking 7.
Got it.
Yeah, so some of this pain is I can't go to, I'm not a Windows user.
Yeah,
like for real, it's been most of my life. The first computer I ever used in my life was a Mac. So it's just like,
oh no way.
Yeah,
That's
I don't
amazing.
even think of Windows. It's so hard for me. Yeah, so part of this is just, you know, Mac OS just doesn't support audio very well, like in that form. But in other forms, it's superior. Like the MIDI routing capabilities, superior in every way.
Oh yeah. Yeah, I'm surprised they haven't added that in. I don't know why. Like,
Well, at Windows, it's such
like,
a niche thing.
media powerhouse OS, you know, like that they don't have.
Oh,
for
you're talking about
Apple.
like the audio, like the levels for each app.
Yeah.
You know, it kind of makes sense. It's a very niche thing, right? Like, I think the typical Mac OS person is likely not having a bunch of different sources of audio playing at once. And even if they were, I don't know if that's a level of complexity that a Mac user would want to deal with. Like,
Right.
even though I'm talking shit, like, I actually prefer what it is now, where it's just like, I just want to turn up and down my volume. I don't want to have to go and like see that there are 50 different apps and have to find the one I want and turn. That's just too much effort. I can't do it.
Yeah. I mean, that's why I use SoundSource. SoundSource is really good for that.
Yeah,
can do
SoundSource is
per-
very good for that. Now here's the problem though. You can't use SoundSource and Loopback together.
You can't. Oh man.
So you have to turn those off. You could use Loopback and Audio Hijack together, but if you try to use SoundSource and Loopback or in the other two together, well, your computer will just turn off. It'll freeze up
Really?
first, and then
Oh,
it'll give you a
snap.
bunch of pop-ups. You won't be able to interact with it, and you will have to physically shut off your computer. Turn it
That's
back
a
on.
pretty crappy failure mode. But
Well, it's doing some things. I would have wished that it would give me an error saying, hey, you can't do this while this other thing is open. But
yeah.
you technically can. There are just certain actions that if you do something, it's going to cause weird shit to happen at a kernel level. So,
God. Oh
Yeah.
shoot. Wow.
Yeah.
Okay.
so yeah, if you are going to use Loopback, you're going to have to give up SoundSource. But you get the same things that you could do in SoundSource and Loopback. It's just more effort. Not as nice of an interface. It's
That's a
not
tough
just
trade-off.
clicking
I've
thing.
grown to become really fond of SoundSource.
Yeah.
But-
Well, to make it, to be fair, you can have them both installed on a system. You just can't have them both open at the same time. So what I do is, like, if I have a stream, I just close it on my MacBook Pro, and I'll open up Loopback if I need it.
Yeah.
But yeah.
Okay. Because I know you said for Loopback you can't do equalizing and stuff too. You have to go to Audio Hijack for that.
Exactly.
But SoundSource has like a mini equalizer, so it does like a little bit of both of what they do, like a lightweight version.
So I was kind of disappointed because I set up the equalizer and all that kind of stuff on SoundSource, and when I realized that I can't use SoundSource to accomplish the goal that I have, I was just like, oh well, shit. Now I have to use Audio Hijack because you can't do that in Loopback, and that's why you use Audio Hijack, is that you need both. One is just to do the audio routing. The other one is for all of the effects. SoundSource mixes it, but you only get a certain level of it, right? Like you get audio, you get volume. I think you get pan, but you don't get the ability to like really route stuff the way that you want. You can route it to a specific place, but that's it. You can't route it to 2 places. You can only route it to 1 place. Whereas with Audio Hijack and Loopback, it literally just opens up Mac OS's internal audio routing to you. And the complexity that you're seeing is due to how complicated like audio or routing in general. It's not just audio. Routing in general is hard.
Yeah. Well, thanks so much, William. This was
Yeah.
awesome. I had like a lot of fun, learned so much, and glad to be on a stream finally. This was
Yeah.
fun.
Well, where can people find you at? How do I?
um, I'm on Twitter at Pratik. It's my first name, PRATIK_IS_. I might do like a little rebrand at some point with my handles and stuff, but yeah, I'm there for now.
Oh my, yeah. All right, I'm trying to share your thing. So, _IS.
Yeah, _IS and underscore again, because that's the only
Okay.
one. It's kind of annoying, but yeah.
All right. Underscore. I hope I spelled this right. Let's see. So just added it. All right. So yeah.
Boom.
Hopefully we'll do something soon. Again. I mean, there's video stuff that we can do. There's also code stuff. Oh, you should tell folks what you do. Like,
Oh yeah. Sure. So I'm primarily a front end engineer. Do a lot of React, JavaScript. Lately I've gotten into like fitness, so like flexibility and mobility has been an obsession. But aside from that, I'm currently on sabbatical. I used to work at Meta before this for around 4 or 5 years, and then before that I was in finance working at hedge funds. So I've been kind of across a few industries. But yeah.
Got the most important part. You're RC alumni.
Exactly. Yeah.
That's our connection.
RC fall 2018, which is I think right after you.
Oh yeah, I think so. I think I was in the summer, or I was in like a mini master. Cause I couldn't quit my job. I didn't want to quit I was at GitHub at that point. I'm like, why would I quit? So
Yeah.
I was glad that they opened that up for folks like me who wanted to do it, but who are like not willing to walk away from what they have.
Yes. Yeah, that's great. Yeah, the mini ones are great. I think I did a mini one too.
Yeah, I would like to do another one soon. But yeah, we'll talk more about that. I do want to let you go. I know you got other stuff to do. But yeah, thank you for joining me, and we will do this again soon, hopefully. Maybe we can figure out a cadence at some point. But yeah,
This is so much fun. It'd be good to get some practice, get some it's a new format for me, so it's like fun to try out and experiment with. So it's really cool.
all right.
But I like that.
Well, I'm gonna send you the link to the VOD afterwards, and yeah, feel free to watch back. Let me know if there's anything you think we should do different or better, and yeah, we'll do this again soon.
All
Till
right.
then, have a good rest
Cheers.
of the day.
Until next time.
All right, man.
See ya.
Peace. All right, so back, maybe. Hold on, I gotta close down Zoom and some other things. All right, yeah. So I'm back for real this time. I'm also gonna close down this. I'm not gonna do any more streaming today. But next time I do a stream, I will likely continue with the Vision OS stuff that I was doing. And we may have Pratik on again. And maybe this will be a little bit of a more common thing in the future. Talking about whatever, right? So today we ended up talking a lot about audio. I don't know if maybe it's obvious now, but I know a little bit about audio. And I also kind of want to talk about video as well. And maybe photography, we'll see. In any case, that's going to be it for today. So if you enjoyed today's stream, please feel free to subscribe on YouTube. Go follow me on Twitch. And yeah, give me a like if possible, because like it helps. In any case, I'm gonna go ahead and call it a day. Peace.